Welcome to Open Frontier, a historic one-day meeting where we'll talk about the future of open science and research. I was raised in a community where access to information was carefully controlled. Education was discouraged, but I loved learning. The people who made the important decisions about what I got to believe did so in a closed room. I never got to meet them and had no say. When people joined this religion, their family members and friends felt like they disappeared. You weren't allowed to ask questions, but I couldn't stop asking questions. And I followed that instinct at great, extreme personal cost out of that religion and into an adjacent institution where instead of knowledge being controlled and closed off, it's discovered and disseminated wide into the open. I found academia. My path to where I'm at now from a poor, edge of poverty, rural Wisconsin childhood stayed true to that same instinct. At every turn along my way, I turned towards open. In high school, when I was scheming with my guidance counselor, Ms. Knopf, about how to enroll at University of Wisconsin-Fox Valley without my parents finding out, I was simultaneously discovering Netscape Navigator at the library, Google, Ask Jeeves. I couldn't believe that somebody we're going to talk to today, had built this thing that I've made all human knowledge, or at least what we'd put on the internet by then, available for free to me in the library at my fingertips. The university system let somebody with no standing and no money access all of what people know. When I got to college, I voted for the first time. Jehovah's Witnesses are not allowed to vote. It was insane that you can have a voice in who gets to make decisions that will affect your life. When I got to grad school, I fell in love with open source. At first, it was because I was so inspired by many of the people in this room who had built the technologies I was just telling you about that changed my trajectory. Like, I got to meet Bill Joy and Vint Cerf and Dave Patterson. These people had taken their ideas and not just published and disseminated them as knowledge, but disseminated them as an artifact that people could use, that solved people's problems. Access, opportunity, and the chance to move up in the world. That's what the internet, the university system, and to me, in my narrative, democracy itself means. Access, opportunity, and the chance to move up in the world. So you can see that idea of open as a common thread through my narrative. The internet, which opens up knowledge, democracy, which opens up power, and, not the university system, which opens up knowledge, democracy, which opens up power, and the internet and open source, which open up access to that power. But open is a much bigger concept than just my story. Open is as old as people are, as old as language. The idea that's in my head can now get into somebody else's head. And written words, so that idea can get out of the room in multiple copies. And the printing press, so that we can make copies of it faster than any central authority could control. And science itself, the method that accelerated the rate at which we can discover new knowledge and best demonstrates this cycle, this compounding loop where dissemination happens And people in this room at the frontier working on the next big problem have collective intelligence. An idea goes off because of the papers you've been reading and the conferences you've been attending, and the next discovery is made. We publish it, open source or paper or blog post, and the cycle continues. Discovery, dissemination, and at every step, more people participate than the last. They participate in the knowing, and they participate in building what comes next. It doesn't just lift one person up or this room, it builds entire industries. The open internet, which is a strong metaphor and inspiration to me, laid the groundwork for a generation of wealth and companies and personal life changes. Open standards and open protocols and open research sits underneath as a foundation for nearly everything we touch in the world around us today. And this America, her strength sits on this simple concept, that progress shared is progress multiplied. That big idea that's so core to our species' progress, openness, is now at risk. The frontier, representing the most important discovery to our species in history, is closing. The data, the people, the GPUs, the models, they're being pulled back behind closed doors. I have spent my entire life on the side of open, and I'm not going to let everything close without a fight. And I don't think you are either, or you probably wouldn't be here. But I'm not going to end this kickoff with a threat. The threat is not why you're here. You're here for the opportunity. And the opportunity is enormous. I mean that without hyperbole. It is the single time in our species, the one time that has never been better to be a person who solves problems. Because we have the biggest problems we've ever faced, and we have the most powerful tool that we've ever built. And that leaves us with the question, who gets to decide? Who decides if the frontier stays open? The frontier will not close on its own. It closes through a series of decisions made by people. Made by you. Made by François and Jan and Percy and David and Matt. We are not spectators. You are not a spectator. Let's not behave like spectators. And it's not just in you publishing your research or staying somewhere where you're allowed to publish your research. It's in leadership. It's in who you can convince that we must keep the frontier open. We must keep the frontier open for our kids' futures. Open needs a heavyweight contender in the ring with the big labs, and we're it. We are it. If we don't do it, I don't think anybody's going to. That's why we're in this room. So let's spend the day talking about how we're going to go do that. And let's make sure we leave the door open behind us. Thank you. Okay, but how are we actually going to do it? We're going to have a series of conversations. We have the live stream running. The day is kind of broken up into two types of parts. We will have conversations on stage that are live streamed, and then sorry to say that this is actually not a conference. It's a working meeting, and so we expect you to do work. There will be breakout sessions and working sessions, which means you need to actually start activating that collective intelligence. This is a moment of dissemination and discovery, hopefully. And the some of the key topics that we'll return to continuously throughout the day are how. We spend a lot of our time thinking about what is the breakthrough, but not how can we accelerate the breakthroughs, or how can we collaborate better, or what advantages must we flex as open that the closed labs who have orders of magnitude more resources than us have. And so we'll kick it off today with a series of panels, and we'll have a fireside later, and we'll have the first panel come up now, which is going to be featuring leaders of open frontier research in universities, in industry, and in nonprofits. So why don't we let the panelists stand up and come on up. We have Nathan Lambert, who is a lead from AI2 on the Elmo project, and one of the clearest, loudest voices championing open right now. We have Bryan Catanzaro from Nvidia, who leads the Nemotron project, the largest open weight model in the West today, probably the most well-resourced open weight model in the West today. We have Percy Liang, who leads the Marin project at Stanford, amongst many other things, and has been a constant voice in open AI research and machine learning. We have Stoica, who leads the STAR and Sky Labs at Berkeley, which has put forward many fundamental systems projects and AI systems projects that have moved the frontier forward. So we're going to jump right into the topic, which is how we have these leaders from labs working at the frontier of AI in the open, and we'll talk about how that's going to go, how we can do that going forward, and what needs to change if we're going to actually keep the frontier open. All right, so let's welcome our panelists one more time. You all have lapel microphones. Okay, good. Yeah. We don't need to pass any microphones around. So, okay, we talked about some questions, but I want to kick it off with one I just thought of, which is, can we do it? Is it possible? Are we all just LARPing here with this idea? Is the window closed? Who wants to take the... I think you're all going to say that it's not closed, but maybe somebody wants to say it's like too late.
I don't think it's closed. Like, it's not closed. It's always different. And you have another question that's like, what do you wish you would do differently? Oh, yeah. And it's like, I was thinking about
Let's
this.
Do that one. Hold on, let me ask the question since you have a good answer for it, it sounds like. Assume in a year the window closed and we failed. What do you wish you'd done differently today?
Yeah, so I think this is the fallout of your call to action in some ways. And it's like, I think a lot of dispelling what people are saying is so useful because there's so much talent that buys into stories that are not necessarily factual, but they're just things that are repeated in rooms very close to this around the Bay Area that like you can only do a lot of research in the lab.
What's like the most potent one you can think of?
You can only do certain research in labs, and your research is far more impactful at the labs, and like only the absolute cutting edge of models matters, and like you need like all of these FOMO-inducing kind of ideas.
There's another idea that I hear a lot, which I think is really dangerous, which is that open technology is unsafe, and that the only way to keep us safe from AI is for a few selected people, priests really, to decide what we get to think about. And that's safer.
Yeah, those are two of the biggest ones. You can't do frontier research because you have the resources in the open, and you shouldn't do it because it's unsafe.
This is what they use to take the people. And I think the people are the most precious resource. I mean, it's like I recently left AI2 and I watched so many people that were so bought into this kind of, they didn't give up, but they were presented a door that was much easier to take to go to a more closed place. And it's like, I think that these narratives are what makes it easier for people to do this. And
I think just to add one other thing, I think there is a sort of a certain framing that comes with the frontier labs where there's a kind of you're building the AGI and this is going to be it. Whereas I think the advantage of openness is a sort of much more broad platform in which the world can build different AI of different shapes. I believe that we are very, very early in the whole game of AI, and in 10 years this will be kind of an unrecognizable point. And I think that having the know-how disseminated so people can build models of different for sciences, foundation models for astronomy, in biology and different types of form factors is something that's so vast that I think just a single lab cannot build.
Yeah, so I think that, let's talk about the models and open source models and these frontier labs and proprietary models. I think that obviously to build a model, you need three things, right? You need compute, you need data, and you need people, right? And I think that, when you think about any effort in the open source, to compete, because eventually I do think that you need to compete with this kind of vertically integrated labs with these silos. You need, at least in one dimension, to match or to be better, right? And one dimension where traditionally open source was better is in people. Because as you know, when an open source project, and Matt can say that, is not only about the artifact, it's about the communities you build. And what an open source it's actually a shared artifact which enables the dissemination of knowledge and get many people to participate. So, and I take that to heart because let me tell you a story. How many people here are old enough to were at SOSP in 1995? It was this kind of exokernel and spin and so forth. I remember it was my first SOSP. And it was it was a panel basically saying, is operating system research dead? And why is that? Because at that time, it was Microsoft was dominating 90-something% of the market. Then Apple was having a few percent. And then there were these kind of different flavors of Unixes, right? And different kind of groups trying to kind of standardize. It was OSF1 or something like that. So there was no kind of chance. And then a few years later, it was Linux, which changed everything. And one of the reasons people are saying it is dead is not because there are still some open source, but it cannot match. For instance, Microsoft has hundreds, thousands of engineers working on that operating system. How can you beat that, right? But eventually, Linux obviously won, at least on the server side and so forth. And I think that one of the main reasons it won is because it enabled a lot of people, because it's architecture and whatever, to collaborate and to contribute. Even some people from these companies are contributing. So my lesson, what I want to get here is that I think that the most important things we can do is to make sure that we enable as many people, as many organizations to contribute. That kind of should be the focus, which is hard. It's harder than traditional operating system because you need also GPUs and so forth. But if I'm looking back, and this was a long-winded way to answer your question, I think that our real chance is to figure out how can we all collaborate, how can we enable as many people to contribute, how we can enable to have this kind of all this knowledge about how to train a model and whatever, mid-train, post-train, to get to as many people as possible, and how to enable them to contribute back with new ideas and things like that. So if we are going to fail, it's probably because we were not able to do it.
I want to, if it's possible, I wanted to just add on to that. I think we also need to stand up for the philosophy of pluralism and openness. I think it's under threat right now. I think AI is such a new technology. We're not really sure as a species how to interact with it. But there's a lot of voices that are calling for it to be very tightly controlled. For some reasons that make sense, right? I think safety is really important in the development of AI. But it is, if we believe that open technologies are necessary for the future of humanity, which I do, And I've been very grateful for them. They've made everything in my life possible. And I really appreciate your introduction, which resonated really strongly with me and rested on so many contributions from the whole community, right, that you had access to this. AI is going to provide access to billions of people to ideas if it's accessible and if they're able to use it. But if AI is controlled by a very small set of people in one particular place, that I think really puts limits on what ideas people can interact with and how they can interact with them. We've dealt with this in the past, right? Like, it used to be true hundreds of years ago that in many civilizations that it was considered unsafe to interact with certain ideas, right? And then we had the Enlightenment, and we realized actually it's safer for us to disagree. We don't actually have to agree on everything, but we need to be able to explore. That's what became the foundation of safety for our society was openness and pluralism. And we decided that one particular idea, one particular person's idea of what safety means wasn't going to be definitive for all of us, right? That we could choose, what kinds of ideas we wanted to interact with. And so I feel like this perspective right now is not heard loudly enough. The voices that are calling for AI to be controlled and basically closed, they're coming at it from a position that it is somehow worse for us to be free to explore our ideas with AI. That AI can be used to harm more than it can be used to defend, which I think is just wrong. I mean, I just think that that's not the case. I believe that the history of technology shows that when things are open, people use them to build and to defend and to explore in ways that are just really fundamental. So I'm hoping that we can, if there's one thing that I would like to add, it's that I hope that we can stand up for the values of openness. As well as the technology.
If our voices, people in this room have been speaking to that. If it's not loud enough, how do we amplify our voice?
One of my concerns in a year is not talking to the right people. It's like AI is going to be the most powerful technology of our lifetime, and therefore likely one of the most closely regulated. And it's like I worry that I don't do enough work to talk to the people that are making those decisions or figure out who they are. Because there are people who are very worried about the top open models being banned in the next 3 to 6 months. And it's like, if I didn't try to understand and participate in that discussion, it's like, obviously I would go astray to my values.
So it's talking to the right people who have power.
Yeah, so it's like very easy for us to come to agreement here, but we need to figure out what the coalition of people here that can correctly operate in the world of DC and understand how they think. I think this is very important this year, and there are more real threats than there were in the past.
Sean?
So I think it's very important. I discussed with many people about this, and it's a very hard problem. And one of the reasons the problem is hard is because a lot of arguments that these labs are making are based on the fear. And fear is one of the most powerful emotions for humans. It's like the negative emotions are more powerful than the positive ones. So just recognizing that, it's very hard. But the one thing I think we can do is to have continuously and relentlessly, also talk about the positive aspects of AI. Because then the argument is much easier to say, yes, but look here, right? All these other positive transformations the AI can bring in society and improving people's lives and so forth. So I think that's I would start from. And just to counterbalance a little bit. Because, I tried, for instance, there are all of these kind of bogus things about, biological things and things like that. It's just hard just to defend against this kind of fear-driven narrative. that
It's
just
almost like we're in
provide the
1830 and Faraday has just invented the electric generator, and we're trying to imagine all the bad things people could do with electricity and then ban them before, you know, it's
Yeah,
like.
but that's again, you can tell them it was things the same thing with radio and everything. But I'm saying that from my own experience, and I can go on and on why all of this, you know, discussion, and there are good arguments about why, you know, all of this about security and again, like biological weapons, all of these things is kind of at some level are a little bit bogus, all these arguments. But you need to provide alternatives, right? It's like you need to provide, and it's too little today, even in our major publication where people talk about the positive side of AI. And I think that's kind of fundamental. And the more you talk about the positive side, it's like Percy, you are saying, it's like it's not this kind of AGI, which is unknown. Unknown, yeah, humans are also very afraid about unknowns, right? Because this is how we survived, right? Being afraid about unknowns and running. But this is, you know, it's also give AI a much more impersonate AI right now. It's doing this really, solving these really kind of mundane problems much easier, much faster, and things like that. I think that's kind of.
Yeah. What's the analog to 10,000 geniuses in the data center for intelligence that is diffuse and available to everyone? Like, you just say geniuses on people's MacBooks? Like, if they're
I think
going to
Jan
download the
actually,
weights.
coming from peer-to-peer, has this very literal research background in dissemination and distributed power when it was about networking.
Well, I think we also just need to lean into diversity, like Percy was talking about, that, you know, AI is going to be, like, the frontier is so huge, right? There's so many different dimensions of the frontier, so many different ways that AI is going to change things. And so this narrative that, like, AGI, like, one day it will be declared and then all fields will be, you know, somehow subsumed, I feel like that's a narrative that leads to a lot of fear. But a narrative of, like, AI is going to be diverse as the people using it, and people are going to use it in so many different ways to do amazing things. That narrative isn't heard as well.
I think but you need to recognize that that narrative, it's absolutely real. You know, I'm talking with people almost every day, some of the former students and so forth, and they do believe this kind of, many of them, surprisingly number of them, as you know, all of you know, right? You know, it's like they believe that, oh, in 2 years, we are going to have AGI. It's going to solve everything. So what I'm going to do? Well, I'm going to do for the next 2 years, I'm going to join one of these labs, right? Because
the 2-year
I'm going to
number
make
is like
some
showing
money
up a lot.
because I don't know what will
6
happen
months.
after that, right? And they are actually, these labs, they are selling this, right? This is the one who is to recruit it. You know, in 2 years, it's going to be too late, right? It's like including
AGI is already here, you know, by most definitions that I care about.
But it's not, you know, it's in the sense that kind of the metric is like people. You know, we educated and people kind of like us, they genuinely believe that in 2 years, the AI will do their work and they are not going to have kind of what to do.
It's a very general thing.
Real,
It's sort of the
right?
singularity, like it will do all work. It will kind of have, nothing will really matter except what you do in the next 2 years is the sentiment that I'm.
Exactly.
I mean, I think the most important thing is it has to be a credible, viable alternative.
Yep.
Right. I think we can talk all we want and, you know, feel good about diversity, but at the end of the day, I think people make decisions on what models they want to use and how they want to incorporate AI, and it's not
Users.
like,
You're talking about the people who use it.
organizations, users, researchers, developers, whoever is interacting with these systems. And I think that obviously everyone will want, I think most people want open, right? It's just that there is nothing, like what are the alternatives? Like the frontier models are really great, right? And I think people think short term about like, I need a model right now. Otherwise, my business or my research project or whatever is going to collapse. So I'm just going to take that. So I think we absolutely have to, you know, besides kind of the narrative, actually stitch together a viable, you know, plan.
Maybe the one observation is we're talking about fear of risks, so fear of biological weapon creation, fear of cyber taking down the global economy, and then there's also fear of missing out. And that one is you're going to go where their most resources are and where the best minds are, and that's where the perception is that's happening in the closed right now. So the viable alternative you're talking about is more addressing the fear of missing out decision making. That like people need an alternative to continue to do frontier. They need to be perceiving that there's frontier AI research happening in the open, and they'll pick that. You're saying.
I think that if there's two parts: the users and our students who are thinking about the next career options. If there were a clear alternative, like if you join, we will definitely build the open frontier models. This is going to be at least as good as all the open or the closed models. I think actually a lot of people would go for that. Yeah. But there is no such thing to join.
Yeah.
Why
well, that's
no
not true. I mean, I'm leading Nemotron, so
Yeah.
I mean, it's not the case that that's not something we're trying to build. It's the case that we haven't succeeded all the way yet. But we're making progress.
No, I mean, all of us are
And-
trying to do
right?
this, but it's
And you have the open ways from China.
Yeah, exactly. China's
Right?
doing great
I mean,
stuff.
you
So you
have
can join-
ULM 5.2 and so forth.
yeah. So you can join.
Wait, okay,
Vint
wait.
Cerf.
So,
No.
Like, you- are you disagreeing
There's a
with
truth
the
to it,
fundamental-
though.
I'm just saying, it's like actually, I think that the danger actually are, in some sense, much more structural and bigger. What happens, because it's clearly that at least some of the labs will be happy if the open source will be strongly regulated as much as they can. It's even banned,
Yeah,
right?
yeah, that's very
So that's
straightforward.
kind of one of the biggest dangers actually we are facing, right? So, and again, you can think about yourself what is a reason behind that. But I think that's what we want to defend against. And that's why I think that constantly talking about the positives sides and what AI is enabling, what kind of, and it's like, why do you think, in some sense, it's like in China, which now builds pretty powerful models, if you look at the sentiment, it's much more positive towards AI, right, than the US.
But
it's like
okay,
60, 70%.
you're conflating a couple things. So we keep switching back and forth between the researchers and the users. Researchers, by and large, are optimists about.
But it's not enough,
the
right?
technology,
Because the people and so forth are going to drive the power, the politics, right?
The people, the users you're talking about.
Yes,
the
right.
economy.
If 70% or 80% of the American public is going to be against AI in one shape or form, it's going to impact regulatory framework.
Yeah, it's like
And
banning
that
Chinese
Sure, no,
models
I-
is
I
beyond
like
possible.
that.
Absolutely.
But
We are not-
I want to pause that because I want to come back to this lively debate. I think that was just kicking off here between Percy saying there isn't an inspiring open alternative that people feel like is that heavyweight contender in the open right now that is capturing enough of the best minds to come work on it. And it could be because it doesn't feel resourced enough. It feels like there's not enough of the best minds, or it's like Llama where you have the money and great minds and it's still hard. You can still fail. Which one is keeping those minds? And then, Bryan, do you actually disagree? You think that like you've actually solved it with Nemotron? And that
Well, I
is
don't
the
think I've
spot?
solved it. I think we're working on it, right? I think the community, and by the way, Nemotron is here to support the community. We love AI. We're not trying to be the only thing that's out there. We're just trying to be part of a community of technology that helps people integrate and use AI and hopefully contributes to the creation of frontier technology in the open. And have we achieved what Percy was getting at is oh yeah, everybody wants to work on open technologies for AI because they're clearly the best. In the West, we haven't. I think in China, that's already that is the case right now. And I think we often are fairly focused on San Francisco, which is maybe not always the right way to think about the world. But I also believe the reason I'm here and the reason we're having this here is because there are actually forces even here in San Francisco that want AI to be open, and we are actually doing things. And of course, I'm representing Nemotron, and we're making substantial investments, and I think it's getting better and better. And we're doing that in partnership with coalition. We're not doing it on our own. We're trying to, save resources, save GPUs, combine data. To Jan's point about how do you build something amazing. Well, if you're doing it in the open, then you should work in the open. Your data should be open. Your compute should be used in a way that conserves it as opposed to spends it on duplicated experiments that everybody already knows, right?
Yeah.
So we are trying to get that off the ground, and we're making a lot of progress, and not just Nvidia, but I think also I'm really inspired by what Percy's doing with OpenAthena and Marin as well. So I think although it's the case that we haven't achieved the success that we know we need to achieve, it's also true that we're making a lot of progress, and I feel like the first step towards success is recognizing the progress that we're already started making.
Yeah, no, I totally agree with you, right? I think we will all share this conviction that we will get there. I think that there is a narrative question around what are people, like there's a very clear narrative, like if you join OpenAI or Anthropic, what that kind of feels like. I think for the open, partly because it is sort of diffuse, partly because there's no, we're not promising, 6 months until whatever event. I think it's
We also pay
a
100 times less, and we have 100 times fewer GPUs
Only
for them.
3.
Well,
Not 100
10
times.
to 1,000. It's a wide range. No
Yeah.
billion-dollar salaries in there.
Yeah. I mean, I think for everyone, there is sort of this value function, which is a combination of frontierness and openness, right? And I think people, I mean,
And comp.
when Marin
And comp is part of it.
and comp is
like
part
if
of
you're
it.
taking a 2 to
sure,
10x
that is-
reduction on pay, your pay is fine.
Especially PhD students who are coming from $60,000 salaries and getting like $10+ million per year offers.
Yeah.
And then also hearing the stories about how their friends who joined Anthropic a year ago have gone from their $30 million to $70 million of equity or whatever. So the comp one is also.
So
The comp is real, but I think that, but I do feel like in my experience that the sort of the vision of like, if we do this, there will be a kind of a path. And I know we are all trying it. We're moving in that direction.
So
but
I think
there's
we should
still
dive into
a lot of
dig into that.
we should.
Acknowledge that the people in this room are chosen, or we are here because we're already leaders in our respective areas. So we have many open source projects who are widely adopted in industry represented in the room. JAX, VLM, SkyRL, Marin, Numatron. The list is like dozens in this room. The question is, are we collaborating enough? And is there some sum where the sum is greater than the parts, or a gestalt thing that we haven't achieved yet that we can achieve critical mass on?
Clearly we haven't. I mean, like if you look at what's happened in China, it's really quite amazing, right? That I mean, how many amazing models do we have? We've got GLM, we've got Minimax, we've got Kimi, DeepSeek, and then what? Antling put out a new one this week or whatever.
Yeah.
There's
All of them.
there's a lot, right? And it's not because they have a different solution to all these tough problems that we're talking about. I think the thing that's different is that they decided that they were going to be more open, and that has created synergies that have enabled a lot of really amazing research to come. And the sad part for me is that our community here, we could do amazing things, right? If we were able to work together in a more open way, I think we could learn from each other and conserve all of our resources, build something even more
share
amazing.
resources.
Yeah, I mean, well, it's so there is I don't want to I used to work at a Chinese company actually. I took a 2-year sabbatical from Nvidia to work at Baidu. Which is like an internet company in China, and they have really great AI researchers. I really liked working there. It is not the case that China is not a competitive landscape, right? These teams, they compete fiercely, right? And they're working really hard, and they're competing with each other. So being open doesn't mean that we always agree with each other, that we're not trying to win, right? Like those things, like that's just part of life on planet Earth, and I don't think that's necessarily wrong. But what they've been able to do is, despite all of that, co-opetition, they've been able to sort of build a self-sustaining community, right? That's alive, where information, ideas are able to compound and build, an ecosystem that I think is much, much better than any other open ecosystem. There's no question about that. And so what I'm asking myself is, what can we learn from China? about how to work together. Again, it doesn't mean that we all have to love each other all the time or that we're not competing with each other, but there is a synergy that comes from being open.
There's going to be a topic at the salon this evening that Matt White is going to moderate, which is about a 15-minute conversation asking, can we catch up with China? And can we get, like, how will the open effort? So that can be Chatham House rule, not live streamed.
Yeah.
I mean, it might be worth just taking a moment to celebrate some of the things that have worked well, and maybe we can think about doing more of them. For example, I think the fact that many of both OMO, Nimatron, and Marin release data sets has made it much easier to kind of share. And then there's a Harbor framework for agentic tasks. There's VLM. And
Common Crawl's in the audience with us. Common Crawl.
Yeah, so I think
Common Crawl is foundational to modern AI.
Yeah. Common Crawl.
all proprietary and open effort.
That's right.
Yeah. So I think there are all these pieces which none of us would have gotten as far as we have gotten without the existence of these. So I think that is worth kind of emphasizing. I think some of the pieces where I feel like there is a bit of a lack is, building models is a kind of, as we all know, is a kind of a messy process, and there is a lot of process knowledge. So one of the members of Marin, David Hall, he wrote a nice blog post about open development, and there is sort of this, pick up a report, and you see these kind of magical parameters, like Ada is tuned to this, and here we're using this number of layers here, and sometimes you don't really understand why. You understand that this is the way this procedure led to this kind of result. But I think, as we all know, as we're developing, it is really the implicit knowledge of, like, you tried a bunch of things and ablations, and this worked and this doesn't work, and that knowledge accumulates over time. And this is the knowledge that's very strong in the frontier labs. They have them. That's why they can kind of go to another organization and kind of spin up really quickly. That sort of like very knowledge is something that I feel like is missing. It's not well captured by these clear interfaces.
I agree a lot. And it's like, I look at AI2. AI2, I feel like, made the trade-off between marginally better models and marginally better speed of releasing models, and with the assumption that it was going to keep going and you would keep delivering them at the trade-off of documentation, where it's like even redoing the post-training pipeline is like a bunch of the scripts in GitHub I think are just wrong. And it's like some of the models, I know the ones that have 100% of the scripts, but that's like not that easy. Even the thing to run it is not that good there, and it's just like having the culture of that being a bit better across all the players.
One thing at least we're doing in Marin to try to maximize the amount of process knowledge sharing is we do this open development thing where all the experiments, all the discussions on how we're going to run things are on GitHub, they're in Discord, anyone can join and look at it. So I think that's a step.
And they're reproducible, right? So the way that you get an experiment run is you submit a pull request and then it gets accepted and that kicks off a job. Is that?
Yeah, every experiment, you know exactly what code was run to it. And then there's discussion. So if we post an experiment and Bryan comes like, no, that's dumb, and then he can write
we can add process to make sure that what we discover in the open, assuming that there is sort of this firewall between the dissemination that's happening between the top labs when the best minds move over for the $101 million comp package, there is dissemination happening amongst them. I talked about dissemination in my kickoff talk, right? But there's this wall because very few of them are leaving their $100 million comp packages and coming to work on Marin and just brain dumping that into the open. And you could say it's for safety, but I don't think it is. We're lacking, failing to inspire them to come and include the open efforts and the cycle of dissemination. So the dissemination is happening across Google and Anthropic and Meta, but not coming back to the open, zero almost. Coming out and just being like, here's all the secrets.
Yeah. So I think that it's down about, exchange of that knowledge and collaboration happen through shared artifacts. And we know that it's successful from other open source projects, including in AI or like VLLM or AGLang or
and the internet.
TCP/IP
and
and so forth. Ethernet. And you see that because some of the innovations are going to be in the open source. So the chance, like I discussed, early on I started again, is like, what is a hope, right? What is a hope? The hope is that when you are talking about data and compute and people, that people as a global kind of knowledge you are going to accumulate, eventually that's kind of the hope is going to match and exceed what a lab alone can do. That we should target.
Yeah.
I'll
Right?
say it again.
And
So the dissemination in the open can be better than
the
any one lab could
accumulate
do.
knowledge and in the
like the combined
open
knowledge.
source, in the open community of the open community, should match or exceed what any particular lab can do.
Including a frontier lab.
Absolutely.
just the number of
Absolutely. I'm talking
talented
about
people
frontier.
outside
That's when you
a lab.
can. That's when you can see the line of sight that you can win. And we are talking about the knowledge. We are not talking about, and we are far from that, right?
Okay.
Look here. We are 4 people. How much we are collaborating?
Yeah, let's talk about
Okay.
that. What the heck?
That's my point, right?
Well, I mean,
And we are
that's all that I'm doing these days is trying to collaborate with the
Totally.
community.
No,
right?
I'm not saying because everyone probably tries to collaborate. I talk with
Yeah, I don't think
Percy
it's
and
lack
so
of
forth.
trying.
We are going to talk. I'm talking about the current status, right? So I'm saying that, and we are not talking about people in this room or in the US. We are talking about the world, right? Because with VLLM or AGLang, a lot of contributions and kind of innovation come from outside. So that's kind of you want to do it. So, but the point here is that, like ideally you have this kind of shared artifacts which enables everyone and all these kind of people to collaborate, exchange the information, right? You are going to see all these kind of experiments, ablations. Right, because training, it is an experimental science, if you want to call it a science, right? And this is exactly what the labs are doing.
I think it's not really a science in a lot of ways. I don't know if it's a craft or an art.
It's a chemical engineering process.
Maybe a chemical engineering process.
I was a little bit, like.
Well, I think this is one of the big reasons why it's hard to collaborate. So like Nemotron is doing tons of ablations, right?
Yes.
If I published, 1,000 ablation studies, I think most of the reaction of the community would be like, why did you run that ablation? That was stupid.
But there would be
No,
one
I think
person
that'll be
that
great.
made
But it's
innovation.
not-
I would have-
you don't
Maybe,
need
but a
it.
lot of it's very
Okay,
contingent.
they disagree and we want you to publish it.
Please publish it, and then we'll talk.
And I'm trying,
We will read it.
I'm trying to make Nemotron more open, but the thing is, like, a lot of it is very contingent. I mean, God, like, I don't know if you looked in our Ultra Tech report. We actually put in a whole bunch of pages on the 2 times that our pre-training blew up, right? And we tried to tell you everything that we learned from our most expensive pre-training
Yes.
run ever, and dissected how it blew up. But then, how useful is that
It's
to
very
the
useful.
community?
Because
a lot of it's
every
contingent
single
on that
experiment
particular
is
run.
contingent.
Yes.
Right?
That's the hard part.
But that's why everyone should do
The
this.
marginal value
and if you
on
look
pre-training
across,
knowledge is very
Yes.
high. I think the
Yeah.
information compresses nicely into data and software. And like we should make sure that the many people get their work into data sets that are
That-
really useful.
I
I
mean,
mean, the pre-training one
yeah.
is very
when
valuable.
we do the development, we look at the genome report, we look at your report,
Yeah.
and then you sort of triangulate things. Like if the pre-training loss is blowing
But
up in the sort of the
Yeah.
similar settings, then maybe
Well,
you're onto
you know.
something.
Would
So-
would just like meeting like a Zoom every month also make this go a little more smoothly?
No,
So
but
it's
what
like
is missing
you're
here-
publishing and you're like I love this and you're like
Yeah.
I don't know if anybody
But
uses it.
the
Maybe
missing
it's
here, but the
Well, I
missing
just don't
here.
know. A lot of it is so contingent. It's like, you're never going to use the particular optimizer, the particular
That's
data
fine.
set blend, the particular cluster with the particular.
That's my problem.
We're all
That's
on
not your
development
problem.
trees,
No, but
but
that's
the
what you need
information
to
cross
share,
singles.
right?
Yeah, and is that true that they will never can there emerge a common infrastructure that people would move towards?
I
And
think
is the
that
reason
would
every
really
so
help.
it would
Yeah.
help?
Well, I think that's what I'm trying to get at is that some of the problem that I think we face is that it's an infrastructure problem because it's not so much about knowledge, right? Like
Yes.
the 2 blowups that we had during pre-training, none of them are very deep. This is not like we discovered a new theory of relativity. This is just like we ran into a
understand.
really complicated bug that took us a month to understand, and it's very specific to what we were doing. And so then the thing is, like, how do we avoid everybody else wasting their time and their compute and their people and their data with that, even though it's also different? And so infrastructure, I feel like, is a big part of that.
Seems
Yes,
like
yes. So I think if you want again is like just put a little bit more to be a little bit more concrete. You need things like when I say about sharing artifacts, I should be able to take your artifact, right? It's like the stack, optimizer state, everything. And I should be able to run on my, if I have enough GPUs, on my.
You're talking about an actual model
And-
checkpoint.
It's what?
You're talking about a model checkpoint with the
Yes,
information
model
that
checkpoints and so
the
forth.
lineage used.
And I
Not,
should
not
be
just
able
the model
to replicate
checkpoint,
the
like the
result.
optimizer checkpoint.
Yeah.
I mean, I think you can make efforts to standardize on things
Yes,
as much,
it's
but I
exactly.
think the reality is that different organizations have their own stacks and things that
Yes.
are not going to be identically. The hardware is going to be different, the configuration is going to be
So you want
Data will be different.
You want
yeah,
to
the
make
data will be
possible-
different,
so
and
this is-
everything's contingent anyway. So I think this can't be a blocker for kind of releasing. As a thought experiment, let's
So
say
and-
OpenAI says, we're going to release these like 100 ablations that we did. Are we going to say, no, I don't care about that. That's on your stack. No, I would say like, yeah, that would be great.
So I want to mention, it's very different between, well, this is what I'm trying to reemphasize, is sharing the artifacts or having shareable artifacts. Because what you are saying here is that, okay, you publish and it's great about all these experiments and so forth, but that's equivalent, like in operating systems, I'm reading things from the book. Right? Because there are books describing everything and what in details, how the Unix was working and so forth. But it's very different from getting the artifact, doing the changes, contributing back, and everyone should be able not only to check what I've done, but build on top of what I've done, right? So I think that fundamentally what you want to have, you have kind of the shared, you need to have shared stack, shared data, share checkpoints with the full information, the optimizers, everything. So to be able that if, again, you produce that checkpoint, I should be able to take that checkpoint with the data and then reproduce your next checkpoint, right? This is what I'm talking about. And then if you do that, it's also you allow much more people to contribute, right? Not only the knowledge, but with their own resources.
And
so
it
that's
makes
kind
it
of what
possible
I am-
even for people with limited resources to make contributions because they can jump in the middle of something, try something, and get some signal even without having to do the whole thing.
It's exactly.
I mean,
it's
like
exactly.
Dirk at AI2 would famously say, if you have a loss spike in your pre-training data and you release all the checkpoints in the optimizer state and the data at that checkpoint, like we don't know the loss, but you can load the checkpoint onto your laptop and start poking around at parameters and what the data in the batch, like somebody could do this.
It's exactly.
Like we
it's
wanted
exactly.
someone to do
Totally.
this at AI2, but we didn't have time. And that's
We
somebody.
didn't have time, I think, is maybe
That's-
part of the big problem, right? Because
That's his answer.
Yeah,
It's like we need to get
we
people
need-
here
if
to
we-
have the time.
If we want to work together, then we have to have the time to document. Like open source relies on documentation and discussion, right? And so like the idea, like I think AI has been built in a race, right? Like we're all in this race. And that has prevented us from documenting and from sharing things.
Yeah, but that's the beauty of open development, right? Marin,
Yeah.
there's no extra documentation.
You guys have a beautiful model.
It's just like you run the experiment, it's there.
I'm very inspired by your model. It's not always possible for every institution to adopt that model. I'm very inspired by it.
There are these layers that we can collaborate at with software. Like if we're using similar stacks, then maybe it's more transferable, our ablations or which optimizer parameter settings we're using. But then there's a knowledge layer, which we all agree is something else that maybe is even, I don't know, we all agree we need to share more at the knowledge layer, which is the community, like what can we achieve what the closed labs are doing in the open, which is people can move around and they have very different stacks at the big 3, 4. So we don't need Ulmo, Nematron, and Marin to use, and a Berkeley project to use the same infrastructure for pre-training to achieve frontier, and that's fine. Co-opetition will happen. But what's happening there is a very stifled version of what we could fully realize, which is the top minds are taking a technique and a set of techniques and insights from one lab and applying them to the stack at the next lab when they move. And we don't have as much, in spite of it all being open, we should be doing that like 10 times better than them, where people can move around and take and maybe it is Zooms, or maybe it is actually people moving between projects, or some social cohesion, some like meta science, some science to how we collaborate.
I mean, I think it takes effort to be open. And if you don't prioritize it, I mean, I'm currently, like with Nemotron, I'm trying to get our collection of teacher models released. So in post-training, we have like a whole fleet of teacher models, each of which are specialized in some field. And we've never released those teacher models, but I would like to release all of those teacher models. Now,
I support you.
I mean, it seems like a great idea. Now, why haven't we done it? Well, because it takes work actually to be open. So like, for example, if we release these teacher models and it turns out that they don't pass our safety bar, which we need to have because we're a big company, and of course, these models haven't been trained to be safe. These models are specific to like trying to be good at math or
one actually,
we are trying to figure out how much work do we want to
People seem like they're getting very excited about what you're talking about right now. So we can
in
give
this
you this, like,
case,
feedback.
you need to get to a point, it's the best safety kind of, checks and processes should be in the open source, but it's chicken and egg problem because the models are not the best in the open source. But that should be ideally the endpoint we should aspire.
Yeah. Here's an idea for you. So what are the things you can release? You can release data, you can release weights, and you can release experimental results, like 1B plots.
Yeah.
Right? The data is tough, but
and we are doing it.
I commend you guys. We're using it.
I want to do more of it.
It's great.
Yeah.
Weights can be tough for the reasons you say, but for the third one, there's actually aside from mild embarrassment.
Yeah, it requires like putting down your pride. It's like if you open yourself up to criticism whenever you release something, and people are like, why did you run that experiment? That's dumb. And so people are afraid of that, so they'd rather just not. And then it also just takes time, So like, right now, like, Nemotron 3, that's so old, right? Like we moved on from that long ago. I know the last one just got released a few weeks ago, but for us, it's like so very old. The researchers don't want to spend time even writing up all the 1DB plots.
Yeah.
And so that's like the institutional and culture thing that is very hard to do. And it's like, I fought this firsthand at AI too, as well. It's like, all the pre-training team is like, we hate documenting anything. The post-training team was like a little bit more academic and like liked doing this work a bit more, but that's just like, leadership needs to spend time pushing on this, and it's hard, and you don't see a lot of return on it because you won't get the credit for it personally, probably, but it's like, it is very valuable.
At the risk of sounding like a broken record, again, open development, you're you're putting things out before the model comes out.
Yes.
Right. So
we
in
can
some
do
sense,
this much more
Yes.
easily.
Like
I've said
exactly
many
you put checkpoints.
And
all the relevant
not just
checkpoints,
checkpoints, but all the ablations, and this is what it makes it feel fresh, right? You're giving the community kind of a sneak preview. And I agree with you, like things from the past.
It's just not possible for me to commit to that, but I really support other institutions.
But this is
doing that.
beautiful because we have a Pareto frontier here. Like what Nvidia's got as advantages, Marin doesn't have the same set of advantages.
Marin has different advantages.
Right, exactly. And so I think the opportunity is to foster more collaboration. Like we're hearing things that Percy would love to have access to, and I think there's an oversimplification in the narrative right now broadly that open means wide open, and there's a whole set of dynamics. And Marin is very wide open, so any like David Hall who's sitting right there can take a lot of shit for some mistake he made in GitHub. Like what about this bug? Like that was a stupid mistake to make. That's what you expose yourself to when you publish everything. And like the culture of Marin is on one side of the spectrum. There's other types of open, like open doesn't have to be, you only live stream everything all the time, and you let the world just rip you to parts. It can be tiers. It can be like we talk in a certain set of conversations.
With Nemotron, we're trying to be as open as we can. I think we can do more, but there's going to be things that are never going to be open. Like we're developing Nemotron in a coalition. We have a group of organizations that are working shoulder to shoulder with NVIDIA employees to build features of Nemotron, build the next parts of Nemotron. And they're bringing their own ideas, their own data sets, their own people in a way that they get to decide, right? Because I believe part of working together is supporting independence, right? And so like when we collaborate with an institution, they get to decide. They may not be able to contribute their data irrevocably to open source, right? They may not be able to do that.
How has it gone picking the set of folks in the kind of consortium?
Coalition,
yeah. Yes. How did you pick, and who might you add?
Well, the most important thing about the coalition is that it's about projects. It's about like specific things that we are doing. And
So like users of the model?
No, researchers or engineers. So like if there's a, so for example, we're working with Perplexity. They're part of the coalition. And so Perplexity, of course, would love to make open models stronger because it's good for them. It's good for their business to have good open models to rely on. They also have certain needs, right? Their business, they have their own business, where they're using AI to do Perplexity's work, which is different from like Nvidia, right? Nvidia is never going to build the same kinds of businesses that Perplexity is building. So they have different evaluations. They have different perspectives on what's important. And so they're going to bring whatever makes sense to them, they're going to bring to that collaboration. And they're going to say, hey, let's work together to make this model a little better at the things we care about. So that's what it feels like to work in this coalition. And they're all different, right? Because every group of companies that's working together has a different set of interests, different set of constraints. So we have to intersect all of that and respect everybody's independence. That's how we're approaching it.
Yeah. So I think that obviously we should, the problem is so important
5 minute
that
warning. 5 minute warning. We're going to be done in 5 minutes. So, FYI.
We are looking there.
That's
there
a
are
clock,
two,
I think.
11 and 14.
That is not a countdown
that's why
timer. You do not have 11 hours and 14 minutes left.
That is
Sorry, but I'm giving you the 5 minute warning. We are on a 5 minute warning. I've got a hand signal
so
from somebody with a clock.
so. I actually.
But I cut you off. I was just wanting to inject that we have a 5 minute countdown.
Okay, why don't you go?
Okay, I actually want to say something about culture, right? So we talked about how it is kind of embarrassing if you run dumb experiments, but I think this is a difference between ML and software, right? I think in ML publishing, you generally want to do all the things, double check everything, and put out a paper. And the paper should generally be correct. As we know, not all papers have bugs in them, but they don't actually maybe get fixed most of the time. Whereas software is very different. You put out some software, if someone finds a bug, okay, great, thanks. Let's go fix it. And it's much more of a kind of organic, iterative process, which I think is much healthier. And and I think in Marine, we draw a lot of inspiration from open source software, which has clearly worked to produce higher quality value. But there is a sort of a culture there where you see bugs on GitHub and you're not like, oh my God, those people, they messed up. No, it's like, okay, that's part of the process, where in ML, we don't have this culture. We kind of expect everything to be correct, even though in the back of our minds, we think like, yeah, I don't know if I trust this. And I think that should change, because then I think we can get more into this kind of free, open share.
That's tough. Rewriting culture is tough, though. It's like but it's certainly one of the arrows in our quiver.
So two things. I think that one is kind of clear from this discussion. There are different entities which kind of, there are different approaches which are enabled by where the model are developed. Like, Bryan said, and it's very valid, like Nvidia and so forth cannot open any checkpoints, right? There are certain liabilities need to protect the company against. Broader open source, maybe we don't have that. But one thing I want to say here is that in the open source, it's actually in the open source, classic open source, that open source artifact is not owned by anyone, right? It's maybe, Apache from Linux Foundation, which kind of going to, you have a governance and so forth. But I think this is a very important aspect, right? Because if a model is a result of many organizations, right, freely, contributing, who is training, who is part of the training, post-training, and so forth. So that kind of model is kind of common, right? It's not going to be owned by anyone. And of course, you need to have that with very strong evaluations, safety evaluation, and things like that. But in that particular case, it will be just like Linux or something like that. And it will be out there, and if you are going to use it, and whoever going to use it is going to be liability of that who is going to use it.
I just also wanted to say I'm really a big fan of the OpenMDW license from the Linux Foundation. I don't know how many of you have taken a look at it, but it's basically like Apache 2 only brought into the AI world. Apache 2 was not written for AI, but OpenMDW is. And I feel like it's been a really big thing for us to adopt that license because we believe in what you're speaking about.
Okay, final thoughts. We have like 1 minute, so if you have a concluding punchline.
I go back to when you were saying like the Pareto of our organizations, and it's like Percy and I nudging Bryan to change Nvidia. Like we're not really gonna do a lot in changing Nvidia culture, but I want to figure out ways where like you can maximize your strengths, and then the stuff that everybody else is doing complements that nicely. Because I think that's really how this will work. Is like. We wish you well on releasing more, but like we need to build a world where you're doing the best you can, and then we around that can fill the things in that you cannot do. And I think that's in the near term what would work well.
Yeah, and we want to help enable everyone to do amazing things. The reason NVIDIA is so committed to open technologies for AI is because it's good for our interests, right? It's directly aligned with what we're trying to do to grow the ecosystem. And it's immensely helpful for us to have partners to work with to get signals about what's useful to the community and what's not. Because at the end of the day, our open efforts are really in service of the community.
Yeah, great. Well, you have a coalition already, and this room is you participating in addition to that coalition or another coalition?
NVIDIA is not trying to be the only thing in AI, right? We're trying to support, right? I hope there's lots of coalitions. I hope there's lots of groups that are working.
And I hope the one that we have assembled here continues to meet again and maybe we can at the working sessions get into the weeds of some of the specifics of how we can, each of these organizations at the Pareto can share in a way that multiplies the other organizations maximally. So great, what a great way to end it. So thanks our panelists for this lively conversation. And we can head off the stage and let the next panel come on up. I'll introduce Remzi, who's going to be our moderator. Remzi Arpaci-Dusseau was my undergrad advisor at Wisconsin. He's a computer scientist who's traditionally focused on systems research. File systems research is where I started with him. And more recently, he's become a systems AI researcher, like so many of us. And he is now the dean of the first university college-level AI college. So the College of Computing and AI recently announced in the last 6 months.
Starts tomorrow.
Starts tomorrow. There you go. Very timely. And so, we saw this in the data paradigm where you had things like Yale renaming statistics department to be statistics and data. But we're going to see that play out again where AI gets resorted inside of the institution to take a place that is at the very high level to represent just how profound and impactful it is. And that happens first under Remzi's watch at Wisconsin. So we have the Dean of College of Computing and AI here with us to lead a panel about resourcing frontier AI in the open. Thank you, Remzi.
Oh.
And I'll let you introduce the panelists.
Okay, great.
You have a microphone on.
Oh my gosh, I have a microphone on. Can you hear me okay?
Yes.
Should we sit down? Okay, so welcome, and thanks for being here. What a great panel that was, by the way. It was really enjoyable, so thanks all that participated. Super eye-opening. So we were asked here to join and talk a little bit about resourcing underneath of what's going on in this open frontier space. I think that means not just money. Sometimes resources mean just money, though money's, of course, a part of it. But also thinking about it, we've been asked to think about it structurally, like how the different structures underneath of universities and industry. Oh yeah, you're supposed to be up here too. Industry and as well as our national foundations like the National Science Foundation and philanthropy. So we have a bit of as you can see, a bit of a hybrid panel here. We have fortunate to have I guess another dean. I'm getting used to saying I'm a dean, so so it's a new job for me. Like I said, starting tomorrow. So Dean Jennifer Chayes, she's leading one of the most prominent colleges of computing writ large in the world at Berkeley for some years. We have Andy Konwinski, of course, who you may be familiar with. I, of course, got the pleasure of meeting Andy in an operating systems class, and I remember he stood out because the very first day I met him, he was so excited as I was demoing in class, like how to use a terminal, he really wanted to know my terminal configuration and my Emacs configuration so he could work at the speed that somebody who was more experienced with it was, and I remember that was the beginning of our friendship. And then we have a couple people who couldn't join today in person, but so generously are joining us remotely. David Siegel, who's co-founder at 2 Sigma, as well as a noted philanthropist. Thanks for joining. I think you can hear us okay? Yes?
Yep, very happy to be able to be part of it.
Yeah, thank you so much. And then we have Erwin Gianchandani, who's joining us from NSF TIP, where he's an assistant director and leading some great forces in the federal government. So I think we're going to just start. I'll ask point to some of the panelists, and we'll talk through some of these issues. One of the big questions that was put forward in this panel, in our pre-read or pre-thinking, was where did we really need to change in some of these big institutional spaces? And I thought we'd start with the academy, with the university space. Obviously, I think universities have to and will play a big role in things like Open Frontier. So I thought maybe start with you, Jennifer, and as to get into this question.
Okay. So first, I should say I've only been at Berkeley for 6.5 years. So I was at Microsoft for 23 years before that. And when I decided to go back to academia, I specifically went to Berkeley because at least some of us think of it as the greatest public institution in the world, but also because I believed that by mobilizing people in particular ways, we could really change the world. We could set an example and change the world. And one of the things I experienced when I got there, which was kind of a shock for someone who's coming out of a company, is there was a very strong zero-sum game mentality. And so I realized that I had to start raising philanthropy very quickly so that it was clear we were not just going to take a fixed pie and subdivide it. And so since I've been there, about 6.5 years, raised about $750 million in private philanthropy, not including some big discussions I've got going on now.
What do you mean by zero sum?
What do I mean? Well, there was this feeling that, if we have more students and more faculty doing computing and data science, then maybe there would be less of other things, which, that's where the demand was, but there was a reluctance around that. I also believed that when I got there, one of the other reasons that I went there is because of the history of open source and the history of platforms at Berkeley, because I was at Microsoft and we would routinely reach 1 billion people. And so reaching a few people that the university could reach was not sufficient. But Berkeley is a place, I see Dave Patterson sitting here, Berkeley is a place where the research reached, really billions of people. The effects of the research reached billions of people, and everything we did, and I think Fernando Perez is back here someplace, with Jupiter, that everything that we do could be put on a platform and shared with the world. And so kind of one of the things that I've tried to do in the last panel, there was a lot of talk about the good of AI and really playing that up. And I've received very large gifts, $50 million plus each for computational precision health, which Andy has even invested in one of the spinoffs that came out of this new department between UC Berkeley and UCSF, really driving AI solutions into clinical care. AI and chemistry and materials for the planet, which is something I personally got very involved in and worked with Omar Yagi, who just won the Nobel Prize in the last fall in chemistry. And one of the things that enabled that was that we sped up his synthesis by a factor of 50, which made it clear that it was going to have an effect, much sooner than had been anticipated. And last week we just closed on an $88 million gift, private philanthropy for computational biomedicine, which is really driving AI into accelerating biomedicine. And so our biologists who are involved in that are Jennifer Doudna and Tej, and the head of the Cancer Center at UCSF and the head of immunology at UCSF. And so, this is all really playing up those parts of it. And what I am really trying to do now, so there are people who see how this is really important for health or for the planet, the stuff that Omar makes, pulls carbon dioxide out of the air and other things that are good for the planet. But trying to work with private philanthropists who understand the importance of open frontier AI technology and how important that is, and how we might be able to use a place like Berkeley to coordinate among all these efforts, as we were talking about before, as we heard so eloquently from Andy to begin with, and then we heard some of the, technically, how would we coordinate? How would we almost have a coordination layer at for a truly open 360 open Western model.
So I'm curious, great answer. I think you touched on, very much the philanthropic side of what you're doing, and obviously you've had great success. And I think, a lot of the places where colleges of this type have popped up very closely connect to alumni who have gone off to Silicon Valley, where a lot of wealth has been generated. So,
none of them were alumni.
And sorry, connected to people and people who are interested in supporting your work. Sorry, I'm not familiar with where you raised your money, but
That's surprising to me.
Yeah.
None were alum.
Yeah.
well, so I get that side. But what I was wondering about on the further side of the university is structurally, that's an up here resourcing question. I'm curious what you've been thinking about the structure of our research enterprise and our reward systems, as well as our educational pipelines, and how they play into this discussion around getting, because the previous discussion was really centered on, a large-scale joint effort across many, across the world, I guess, universities and beyond. And what you're thinking about in that space in terms of the structural differences. And then maybe we could also have some other people chime in as well.
So one of the reasons that I wanted to be a dean and not necessarily, and you and I were just talking about this, a college president or a university president, is because I want to be close enough to the research level that I can actually have an impact there. And one of the things that I've been doing is raising money for professorships that are in particular areas that might not get resourced as much through the normal process. Okay, I think that that's really important. And actually, I'm not sure if Tom Khalil is here, but he and I were talking earlier, and I said, some of the money that I brought in for new professorships, we want to bring in people who are very active in open source, who might not have, whose efforts might be going more towards creating things that people use, that a lot of people use, and that bring together a lot of researchers, than simply writing more papers. And so, I believe that being at this interface where you are and I am now, especially if we're doing research ourselves, and if we're going up, we can try to see what are the parts of academia that are not really set up properly to engage as deeply as they need to in order to push this this effort. Now, we've got all these great other people here, so.
So Fernando's here, and I've found it always inspiring to know that he's at Berkeley working on the frontier of data science, having had such massive impact on that paradigm, which Databricks was built around basically a proprietary version of Jupyter Notebook. Like this idea of Jupyter was one that carried as a through line through the entire paradigm of big data and data science and revolutionized the entire Fortune 500 and the global economy, and that the roots of it were in IPython and IPython Notebook, and having that sit at Berkeley at the Data Science Institute is very inspiring. Are there specific tenure lines that you're thinking about with AI infrastructure or AI applications that you're targeting for the open source professor role?
Well, we got a gift for certain lines for materials and chemistry and AI. And I can't see Fernando, but I assume he's, there. Okay. One of them we're looking for, call it Fernando clone. I mean, I wish I could just clone Fernando. That's actually one thing that I hope to do in the biomedical. No. Yeah, but we want, as we're looking for these people, to have people who are going to truly enable research more broadly. And another thing I want to do when I get some time is kind of look at the criteria by which we tenure people. I mean, this is, of course, up to the entire university and things, but you look at different fields, and you look at something like art practice, and you're not looking at the same metrics as you look at for history, which is books, or for statistics, which is papers. And so I think it's really important, if we don't want universities to be left behind, to just look at these things and try to make the case in the normal, through the normal academic processes, which for somebody who was in industry for a long time can seem remarkably slow. But the good thing about them is that inertia means they're not as easy to undo either.
I was wondering if we could, great, thank you for that. I was wondering if we could pop to some of our remote guests talking about maybe the academy and then maybe connecting to philanthropy. So I thought maybe I'd start with David, if you had thoughts on the structural, I mean, obviously, you went through a long series of education yourself, so you understand the university system quite well. What do you see in the university space that might be not only helpful maybe in this open frontier era that we're hoping to participate in, but also might be needing to be rethought? I'm just curious if you have thoughts in that space.
I do. And Jennifer and I know each other. I've chaired since its inception the MIT, the Schwarzman College of Computing. I'm the chair of their essentially advisory and oversight board, and have worked very extensively on academic programs within the College of Computing at MIT and beyond. And it has really affected my thinking of philanthropy quite a bit. And I think I share your views as well. The role of academia in scientific research can't be disputed. It's very important across the board. And I think in particular, as we move into an AI era, things do need to change. People talk about all the changes AI will bring to business. Absolutely. But they're going to bring a lot of changes to how research is conducted, both in the for-profit world, but especially the nonprofit world, like universities. And one of the challenges that I think is occurring is that there is more software engineering that is needed to conduct research. In the past, a chemistry lab was like a wet lab, and now it's becoming digital. And AI is now being used throughout academic research, but in many, many cases, the universities aren't set up to develop the infrastructure, the technical infrastructure to properly utilize evolving AI. And that is one of the reasons that I created the Open Athena organization, which is essentially looking at a hybrid structure. Let me sort of really briefly, if I can, describe the hybrid that my organization has in mind. Corporate research is really good because you can hire scientists into a corporate environment, and then you can assign technical resources to work with the scientists to have them, to amplify their work. In a university, research tends to be done by individuals or very small groups of people, and it doesn't have the ability necessarily, for example, for professional software engineers, people with the technical expertise, like if you're in a chemistry research lab, you may need AI specialists, people who actually understand how to build these things and are interested in the actual technical engineering work, less the chemistry, more the AI component. So what Open Athena initially started doing was hiring, we built essentially a professional software engineering organization, and then we second these engineers to academic research efforts. And so we have people working on, at a variety of universities as partners with the principal investigators. And it's a different model than has been around. And I'm, funding it. It's being funded with philanthropy. And I think it's a good use of philanthropy, to tie it to your question more directly, in that philanthropy can serve to, be almost like venture capital to try to activate different models. And hopefully, if you think of philanthropy maybe as a Series A, maybe other people jump on board for the next round if it's delivering results. And so that was kind of the spirit of how Open Athena came to be. And one of the projects that we've incorporated into Open Athena was Marin, which Percy was talking about. And in the same spirit, Open Athena is contributing software engineering to the Marin project. And so so this is a philanthropy model that is a little bit different than directly. So in a way, you could think of it as someone, and it's all good. You could raise money to endow faculty chairs at a university, which you need to do. But another model is Open Athena is gifting technical capabilities to universities that they would have trouble achieving on their own. And so that is an alternative philanthropic model. And I could keep going, but let me give the microphone back to you.
No, that's fantastic and super interesting. I think, going back to your Schwartzman experience, I think that's another place where, I was talking with their leadership some months ago, and what was, I think, particularly interesting is some of the way they dedicated faculty lines. So the structural change to people, that both are in computing and AI, but also have their foot in a domain, and then thinking about new tenure processes and hiring processes around that. And I think they've done a really good job around that sort of thing. And it sounds like you're doing similar things at Berkeley. I think the other thing that I've been thinking about a lot for our own university is that the Open Athena space. I think there's so much room for opportunity there, because you're talking about basically a professional acceleration of the types of support you need underneath of the whole scientific endeavor. So that seems like a super, so much room for growth there, I think, as, sometimes I think universities get a little bit myopic in thinking about, just faculty and graduate students, of course, at the core of the mission. And of course, that should be a core of the mission. But there's a professional side of it that I think is super important too. And I think that's what you're hitting on with Open Athena.
Yeah.
Some universities have hired or established RSE, research software engineering programs to do this, and that's a sensible way to go. But the Open Athena approach takes it to a new level, because one of the things that we've discovered is if a PI hires a software engineer into a lab, they're not hired by Berkeley, they're really hired by the lab. And if that doesn't really work out, the software engineer can't just go to another lab very easily. They don't have the same kind of career path that they would have if they were in an engineering company. And so this turns off, we've found, a lot of really talented software engineers for wanting to go to a university. But at Open Athena, where our objective is to give them a career in essentially software engineering for research.
Yeah, oh, that's fantastic.
And you're doing it at a scale that I haven't heard of before. With the Marin project in particular, I've never heard of an academic project that sits at a top or any university where a nonprofit was able to come in and add 7 engineers right now, full-time, and with a roadmap to grow that team significantly larger. It is larger than a small startup, and we had this in the lab at Berkeley, the Rad Lab and Amp Lab. We had 1 or 2 engineers that would join the lab, but it was like some sort of threshold that I think they've crossed with Open Athena, where it's a professional team building product that it's at the intersection. It's this new type of innovation at the intersection of academia, of open research and science, plus productization, but like where you're not going to sell that product. It looks so much like a startup, and we're going to try and host the Marin team at Laude Lab, the physical space. And Laude is kindred spirits with Open Athena. We also hire engineers, but not at the same scale for a single research project so far. And this idea of like inventing a new type of organization, people are calling them like nonprofit startups, or we talk about focused research organizations as another, like this, it sits outside of traditional university nonprofit structure, because universities are nonprofits, but they have a lot of like 2,000 years of monastic tradition that we like slow moving, lots of inertia. And then you have capitalism, startup, Silicon Valley, king of that here in the whole planet. And that's like, this thing is basically exactly between those two, and nobody's nailed it before. And we're starting to get like these uplifts of the benefits of both, like this Gestalt thing, this like sum is greater than the parts of the open science and the startup culture being infused into this intersectional thing. So it's really exciting what Open Athena is doing and how we're seeing the product in Marin.
Yeah, that's incredible. So I want to bring Erwin into the discussion a little bit. Thanks for patiently waiting. I think we could of course continue talking about the academy and the university side and its connection to philanthropy, but I think it might be nice to broaden the discussion a little bit into your neck of the woods and what you've been thinking about on private-public partnerships and the role of I think federal government, federal funding. So maybe you could share some initial thoughts there, and we can have a little further discussion around it.
Yeah, happy to, Remzi. So first of all, thanks very much for having me, and thanks for the flexibility to allow at least a couple of us to participate virtually today. Yeah, I've been listening to this conversation, and it's been actually very fascinating, just the tour that we've taken between Jennifer and David and the conversation so far. A couple of things that it reminded me of. We've sort of, over the course of the last few years, certainly with the introduction of AI, but really if you go back over the course of the last, I think 10 or 15 years, just sort of witnessed, I think, a pretty significant phase shift in just what we consider to be fundamental research in this country, and specifically in certain fields like computer science. So I remember, I think it was 15 years ago, almost 15 years ago to the day, I was giving a talk. So my background, for those who don't know me, is in computer science, and also biomedical engineering. And so I was giving a talk to a computer science department, one of the top 10 computer science departments. And at the time, I was talking about the notion of CS plus X. Computer science meets sort of domain areas, application areas, verticals, if you will. And I remember at the time, folks coming at me after the talk, literally coming at me after the talk, challenging the assumption that we should even be having a discussion about CS plus X, because it was, I see Jennifer smiling, so she remembers these days, because it was effectively, we were threatening the the notion of advancing the foundations of computing by introducing this sort of X construct. All of a sudden, we were making computing in service to other disciplines, in service to other sectors, as opposed to advancing sort of the core fundamentals of computer science. And I think that what we've witnessed over the last 15 years or so, and particularly over the last few years with the evolution of AI and machine learning capabilities, is sort of this profound, I'm going to call it reset. Not to say that we still don't have pure sort of discovery, foundational computing without regard to sort of application domains, but I think we've seen this at least evolution, if you will, where now a lot of the drivers of computing research emanate from what are the use cases, what are the pressing research questions that we need to address, often coming from industry, but often coming from a variety of lenses. And so I think that sort of use-inspired research, if you will, particularly in the fields that are represented on this stage today, I think lends us to then having a conversation about the academic enterprise. And I know you asked me from my neck of the woods, but it is from my neck of the woods to some extent as well, because as a leading supporter of basic science, as a leading investor in fundamental science, and given everything else that's been discussed over the last 12 or 18 months around academic institutions, I think it's important for us to sort of put a very fine point on, why are we doing this research? Why are we enabling this investment in this historic 80-year or longer trajectory of academia, industry, government working together? And I think it's because we want to be able to drive innovation and now drive it even faster in light of the competition that we face on a global stage. How do we drive this innovation to the point at which it's going to have real world impact? And I think that we all recognize that, we all want that. We've often said, well, we're going to support basic science, and 10 or 15 or 20 years later, it'll emanate in the form of products and services. And I think that I don't think we can afford to necessarily wait 10 or 15 or 20 years to be able to get there. And so that means that we have to sort of rethink or reset the expectations, or what I think, Jennifer, you said it a few minutes ago, how do we measure or attain success at the end of the day? And yes, we can talk about papers and publications. We can also see what's happening in some of the leading conferences in some of these fields like AI, where they're being inundated with papers and publications, and it's hard to make sense of, what's the needle in the haystack, or what's real and what's not real, right? And so what are some of the other measures or impacts that we should be thinking about in terms of the outputs of the research that we're trying to generate? So I think we spend a lot of time, particularly in my shop, Remzi, so some of you may know, we established a new directorate at NSF, the Directorate for Technology, Innovation, and Partnerships, or TIP, a few years ago. I happen to have the honor of leading that at the moment, or helping to lead that at the moment. And I think that one of our key aspirations is to be able to shorten that time path from research to impact. It doesn't mean that we're trying to dilute or move away from basic science, but it does mean that we need to be thinking about how do we accelerate that, how do we understand what are the gaps and the hurdles to get across some of those valleys that we often talk about, and how do we help researchers really think about those use cases as the driving force for the R&D, and then also help think about how you move up the TRLs much more prominently than I think NSF, for example, the rest of NSF is historically known for, or historically tends to support.
What's a TRL? What's a TRL?
TRLs, technology readiness levels. I'm sorry, technology readiness levels. So thinking about this, or adoption readiness levels, there are various ways of thinking about this, but thinking through where does the technology sit in terms of its readiness for commercialization, market, consumption, utilization by writ large, and so forth. I was just going to comment one more thing, and then I'll yield the floor back, which is I was thinking about this Open Athena model that was just referenced, and you mentioned the notion of these independent research organizations. I think that we have to always remind ourselves, regardless of institution type, whether it's government, it's academia, it's industry, necessity is sort of the mother of invention, right? And so we have great case studies in the room of how small teams with sort of a focused investment over a period of time have made significant inroads that have given rise to risk computing, or that have given rise to RAID or other types of solutions that are now widely adopted, right? I think that in that same context, we also have to be open to not just what are the outputs and what are the measures of success, but we also have to be open to new models that can leverage academic institutions and the history and the benefits of academia, but maybe also bring in other perspectives and other approaches too. And so, on the heels of some of the great work that's been done by Convergent Research, Open Athena, and others around these sort of independent focused research organizations, that's what led us in NSF TIP over the last few months to roll out X Labs, which we really view as an opportunity to support, to take a bet on a team that wants to aspire to overcome a key challenge or bottleneck to really move up those TRLs, if you will, advance across the technology readiness levels, and help bring about real world solutions in a shorter time scale. And rather than have to constantly be in a battle for funding from NSF, submitting proposals to NSF and on a regular basis, can we provide some consistency there? Can we provide a sustained runway of investment over a period of time, 5 or 7 years, for that team to be able to overcome some of those valleys that I was talking about as you think about use-inspired and translational research going forward? So I could go on, but I just think that this notion of being willing to think outside of our comfort zones a little bit, being willing to adapt to the moment that we face and be opportunistic in the moment that we face, I think that's to me a secret sauce.
I'd like to mention, the first two domain-specific gifts I mentioned for computational clinical care, computational health, and computational materials and chemistry. In those gifts, we didn't put in research scientists. And in this gift that we just got for computational biomedicine, we do have 4 research scientists for 6 years. And that was due to the realization that there's incredible acceleration, and we wanted to take the pressure off because it's hard to raise money for highly paid research scientists from, for example, NSF funding, and so they would really accelerate the translation of some of the breakthroughs that we were expecting. So, it seems like we're all converging on this as something that that we really need to somehow put into academia in order to realize the benefits of it more broadly.
Yeah, no, that makes a lot of sense. I mean, I think we've seen, even at Wisconsin, like some of the early like database research that was done there. I see some of those folks in the room actually, as well as some of the early work on distributed computing. A lot of that moved forward because there weren't just professors leading the way, but there were staff that helped build the software beyond just the graduate students, that helped the longevity of software, and some of that software is still in use today. So I think that's going to be increasingly true as we work on bigger and bigger projects that are trying to build open source ecosystems around them, that you need that kind of wood behind that arrow. So I wanted to maybe, please.
If I could just quickly add.
Yeah, please go ahead.
I think I think we're all in agreement here, which maybe doesn't make the discussion exciting, but I think it is really worth pointing out that there's urgency in what we are all talking about here, in that the changes are happening very quickly, and there are some people who take the position, I certainly don't, I don't think anyone here does, that because of the nature of AI, academic research will become less important. And I definitely don't believe that. In fact, I think one of the strengths of America is that we have had a very healthy partnership between government laboratories, the private sector, universities. You've had, grad students that bring ideas into the private sector. We have, essentially, I would credit American success in science, our advances in even AI today, to this ecosystem, which has brought many different kinds of talent to the table. Now, at the moment, because the nature of how research is being conducted and the various other structural changes, it's time to reinvent how it's done. And we shouldn't give up on any form, but what we should do is look at it and look at what's working and what isn't, and using various kinds of funding. Philanthropic is what I think is going to really come to the rescue here. Try out lots of different models, and then we see what emerges. And I just want to emphasize, this is really critical for America.
I agree with David that we shouldn't just keep agreeing with each other, but because I think we should find something to debate about. But I'm really excited that from my perspective of having done the PhD 2007 to 2013, for what I kind of believe that there's been this setup of a paradigm change in the academy, in the way that that science has to progress, open sciences, if you think of that, open research, and that's been set up for decades. And there are these paradigms, and I think we have to we are entering a new paradigm where research has to be done differently. We had the SAIS NSF, which was really an anchor, and DARPA, these other paradigms that were how we fund, how we collaborate between industry and other institutions, how we share, and then the value system. So for so long during my PhD, how we wrote for citation count. H-index was a value that was the number one. And doing impact research, or research that ships, as we talk about it in this community, wasn't the thing you got tenure by pursuing. And now we're re-engineering tenure lines, and we're taking philanthropy in this whole new series, and we're seeing a new directorate at NSF that is emerging to anchor on this intersectional research approach. That is what I think is the new paradigm that sits at the intersection of what the best ways startups can have velocity, and the way that academia brings the legacy and the approach to dissemination and to train your replacement, and I mean all the things that we know academia has, but as adapted to having to move much faster than we ever have. And even the TIP directorate represents a fundamental new way of funding, but if you combine it with philanthropy, which can bootstrap, I very much resonate with David's approach or proposal that philanthropy, it's not gonna be able to put forward the way that a sovereign wealth fund or just a nation can put forward tens of billions, hundreds of billions of dollars if the administration at that time and Congress thinks that's important. That's the deep pockets, but we can prove concepts with $1 million. We can prove concepts with $5,000 of credits for the newest open model. I know Laude has lots of examples of giving a grad student $5,000 to get the paper done, to get the big tweet out, to get other people to buy the idea of a prototype. So it's actually where David has done a big program with Marin. We've done these slingshot programs where we're giving out sometimes just advice, sometimes engineers, sometimes grants, and just like a couple of GPUs or something.
Erwin wants to jump in, by the way.
So sorry, Jennifer, I think you want to weigh in, but let me just say something really quick in response to Andy's comments. So a couple of things, right? I fully agree with the dialogue just now that I think there's tremendous opportunity for philanthropy to experiment and so forth. I would also just, and in fact, by the way, it is absolutely the case. Credit to, I'm going to say something that will, I'm sure, get me in trouble, but credit to Convergent Research and some of the other folks who have been pioneers of the focused research organization model, the FRO model. I mean, we have built on that as we think about the evolution of that in the context of the federal enterprise and getting to the point of XLabs. So So that's proof positive of experimenting, and then now the USG coming in through NSF TIP and saying, hey, we want to explore this model from a federal context as well and see what we can do. And in this case, particularly in the context of the mission space of the TIP directorate within NSF. But I think I don't want to sell the government too short either. I appreciate that, that there's been an interesting environment over the course of the last many months. But if you look very carefully at the messaging coming out of the White House Office of Science and Technology Policy around some of what they want to see happen in science in this country, if you just look very carefully at that, you will see a messaging around experimentation. Right? I think that there is growing appreciation that we shouldn't just be the world leaders in some of the topic areas in which we're innovating. We should also be the world's leaders in terms of how we're innovating in those topic areas as well. And so, if you look at everything that TIP has done over the course of the last 4.5 years, for instance, be it X Labs, be it the Regional Innovation Engines program, be it the tech accelerators and so forth, these are all pilots that we start, experiments that we start. We're taking sort of a science of science approach to things, trying to test out a hypothesis, a theory of the case, and then trying to see if we can validate that through the investments that we want to pursue. You talked about partnerships, Jennifer, a few minutes ago, right? Let's just take 1 second on engines. Regional efforts to grow R&D ecosystems that give rise to local level innovation. We invested $135 million for 2 years in 9 engines to support the burgeoning of these ecosystems in different parts of the country. 2 years, $135 million. Those engines have unlocked more than $2 billion in matching commitments from state and local governments, from private sector interests, from venture capital and so forth. Venture capital that's going to parts of the country that frankly wouldn't have otherwise gone, right? And so I think that that's part of the puzzle. We should all be doing it. I just don't want to, maybe I'm biased since I am at NSF, but I just don't want to sell NSF short in that. And that's why we love to partner with philanthropy when it makes sense. We love to partner with other stakeholders as well.
I want to bring us back to something that was really, I felt the topic of the first panel, which is that we need to figure out how to enable, both from a competition standpoint and from a funding standpoint, the coordination of the West building the open frontier model. We really, really do. And, I was thrilled, hearing more about Marin, and I know what Nicholas has done, and Nematron is fantastic. And of course, Jan, I believe, has a great solution to some of this in building a coordination layer that would allow people to come in and build. But I think that is something that we as a community, and by community I mean now not just the universities, but the philanthropists and the government have to take on. And quite frankly, I do believe it's a huge national security risk for us not to be doing that. So I would, I don't know, Erwin, if you are in a position to spearhead some of this. I'm talking with friends who have more military ties. I mean, I think building the open ecosystem is really what the United States and the West need right now. And how does philanthropy enable bits of this? And then how do we coordinate with the federal government? Because it, I think, is very consistent with bipartisan aims, actually. I mean, it's probably some of the only things on which we can get bipartisan agreement that, we need to be competitive with China.
But if I could jump in there, and I think you'll probably get a lot of agreement that we should be doing that. One thing we were asked to consider were roadblocks to getting there. And I think what came up in the earlier panel, particularly germane here, is the public trust. And I wonder if we could talk about that a little bit. my own journey in this space, I felt like this AI tidal wave was coming a few years ago. I started talking to people about it, like Andy and my old advisor, Dave Patterson. And started talking about a college which puts AI kind of front and center. And the enthusiasm and support I got from people like that was incredible. Like, yes, you should go do this. And so I spent a few years, and somehow that sounds like a long time, but a university time, that's very quick. In a few years, we went from nothing to a new college. The thing that happened in the past so many months was, as I started speaking to what I would call the other 99% of the population about AI and the transformative nature of it, it's a very different conversation. And it's been very eye-opening for me over the past so many months. In not just, there's of course fear, there's a lot of distrust, right? Distrust is at the center of it because, and you can talk about whether this has been created accidentally or on purpose, but there's a great sense of distrust among, like I talk a lot to our alumni across the whole range of our university. There's not a sense of that responsible people are driving forward these changes. And I think that, and unfortunately, I think that impacts our ability to get together and work on things because we need the public trust and public support in universities and in the open world, where I think the trust would make a lot of sense, but it's going to have to be earned. I think right now we're starting at a disadvantage. So I'm curious what the other folks see in this space.
Well, I have a theory. On that. And by the way, I'm a little under the weather. That's why I wasn't able to make it out. But I'm at the Aspen Ideas Festival, and I did spend a little time there yesterday, and I can assure you that you're correct. The talk of the town here is about the distrust, and I would, to partially explain it, there is a very large level of secrecy in the production of AI, and it's natural to distrust something that is being done secretively. And, so one of the reasons I think that the open approaches that we're talking about here are so important and really should be embraced by industry too, is that if all of this were done more transparently, if more people had access, as has been the case in open source throughout the computer history of recent times, it just builds trust because things are, out in the open. And so, imagine a situation, which I think would be very bad, that, a small number of firms control the technology. The government in secretive laboratories is evaluating whether or not the technology is suitable for use. And the general public and scientific community, doesn't really have any access to any of that stuff. That will breed more and more distrust. And so I don't know if this has been mentioned here, but I mean, there are many reasons why you want to have an open effort, but I think it will help to promote trust.
I think that, and Jan had brought this up and all of us know this, that the big closed model companies have exploited people's fears. Fear is a way of generating strong emotions and making people believe that what they have is incredibly valuable. And of course, they're very soon going to be coming to public valuations. And I agree with what Bryan said, that it's actually safer if you're doing it out in the open, because then everybody can hack at it in a way that they can't if you have very few people working on this stuff. I do believe, this may seem stupid, but I think we need a marketing campaign as successful as the marketing campaigns of some of the closed companies, because I think we just, we're trying to do it by talking to some alumni, talking to colleagues, and the other side is doing it in a much more professional way. And I think we should be, I mean, it's kind of stupid. You know, we bring a knife to a gunfight and we wonder why we're losing.
And it's not a silly idea at all. There are a lot of reporters and journalists who are now taking an active interest in AI, and many of them are here today. So there's a dozen or so folks who believe that it's as important as politics or any other concern in the history of our species to cover this and bring, you know, a lot more light to the narrative than what my cousins in Illinois currently think of AI. So that's one thing we can do.
It's not just your cousins, it's my colleagues at the university. I mean, you know, it's just, it's been a very effective fear campaign.
Yeah. One thing we're doing at Laude is working with a diversity of universities, communications departments on our grant programs. The Moonshot program that Dave is leading, which will probably come up later in the day, is we give resources to labs at universities, but we also, in addition to these multi-million-dollar grants, 10 million over 3 years, we also provide support that includes comms support and a team up, introductions to reporters, helping students with an amplification strategy for their tweets, for their research. And I think that there is an opportunity for this new thing that we're prototyping, this new paradigm where we do research at this intersectional way, to have communications be baked in at a order of magnitude higher level of importance than we've done before for past technology. Like, we have to be much more proactive with the way we message this.
By the way, it's not only your relatives and my colleagues, it's also the Congress people. Okay, it's been a very, very effective campaign. And so I think also, you know, there's no question that more open would allow it to be tested better, would allow us to build in safeguards, would allow us to do things like, why do we not have something in AI that looks a little bit more like what we've been able to do in cryptography? Why don't we have something like a one-way function? I mean, this is the mathematician coming out in me, but why don't we have models that we can build that have something in them almost like a one-way function in cryptography, so that it is a lot harder to go outside of certain bounds than it is to remain within those bounds? You know, this is not something that one of the frontier companies would be incented to build. But if we had an open model, we would be incented to build this.
Well, we're incented to build that even without an open model. This open science community is the best community to do safety research.
But safety, you know, sometimes safety is just, I'm going to have people hacking at this and see where it breaks. And with all the possible ways in which something can break, you need something a lot deeper than that. Yeah. Something analogous to public key cryptography with one-way functions or something.
Alec Radford, who's also got sick, isn't able to be here the whole day, but I think he'll be making appearances, and he's leading a project that they published on a month or so ago, a month and a half, called Talkie, where they essentially are cutting off the date at which this small medium model that they're training to, like, early 1900s, and asking questions about how much generalizability can a model that's at frontier level capability but stopped before many modern economic and scientific discoveries were made. How capable is it? If you do then, like, lobotomize certain parts of the training data, can you make a science out of understanding what's in scope and out of scope when you have reasoning models that can rediscover things versus what it has has not been allowed to memorize? There are other folks doing interpretability, and there's there is an active science, but I think,
by the way, any of you who still care about Turing Awards, there would be a Turing. I was on the Turing committee for 6 years. If you could get something like open key, you know, like cryptography for AI models, a much bigger thing would be, of course, that you would help the world
Jennifer,
a great deal.
I think you're right. You know, some sort of PR campaign is needed. Some of the things that I have heard recently that that I don't agree with are things like, AI is so powerful and dangerous that it can't be open. And, my retort to that is, if it really is so powerful and dangerous, we have to have it be open because we need to understand what we're up against. And, but, I think, a key point here that, just amplifying what you're saying is that the more people that understand how the technology is built, what it can and can't do, how the safety mechanisms are actually being built into it, the more good ideas we're going to get for being able to do a better job. And this is the whole benefit of open source. I like to say, I actually, when I was at MIT getting my PhD at the AI lab, I sat next to Richard Stallman for 2 years, and I was debating him on the merits of open source, and he was just forming the ideas. And I was taking the position that, Richard, you're going to destroy the software industry because companies need to make money off their technology. And it took him 2 years. I'm a very stubborn guy. But 2 years later, Richard convinced me that I was wrong. And it is actually because things have, in my opinion, been open source, so many people have learned, and then the technology improved more rapidly.
So I think we're at oh, sorry, go ahead, Erwin. Go ahead.
All right, if I can just weigh in on this point, I have a couple points that I've been thinking about here. So first of all, you talk about a public campaign, public awareness campaign. I don't disagree, but I would actually go one step further, or maybe before you even get to a public awareness campaign. I think the fundamental issue that we face is most folks don't necessarily understand what AI is to begin with, right? I mean, everybody talks about it, everybody hears it, reads about it in the news, especially these days. I know I wake up every morning and there's another story about AI in my news feeds. Yet, I would say the vast majority of Americans don't actually know whether this device has AI on it or not, what the component is that has AI, right? I mean, I think that's the starting point from which we have to understand where that public awareness campaign begins. And so, we've been talking a lot lately about trying to get folks equipped to sort of a basic literacy of AI to begin with, so that you can then get them to the point, those who are interested, to get to the point of thinking about how they can be fluent with AI systems, actually use an LLM to net positive effect on their daily lives, whether it be productivity or figuring out where they want to go travel next or what have you, to the point that you can then get them to be proficient with AI systems and become the next class of developers of these tool sets going forward. We have a whole effort, AI Ready America, which is really trying to think about, the U.S. Department of Agriculture has pioneered the cooperative exchanges for ag all across this country, leveraging land-grant universities. How do we do something similar in the AI space? And how do we help folks be able to become situationally aware and move up that readiness scale without necessarily having to move themselves to a big university or a big city or something to that effect? So that's just one observation that I wanted to offer. The other is, Jennifer, you turned to me a few minutes ago. I didn't get a chance to respond about the idea of, what could the government do in the context of open models and pulling people together? I mean, I'll give you one case study. We got a proposal from our colleagues at AI2. I think some of them are in the room last year, looking at ways in which they could develop fully open AI models for furthering the scientific enterprise. And we saw that proposal. It reviewed very well. And we actually then ended up bringing in an industry partner, Nvidia, so that we were able to double up on what we invested in that effort. So instead of a $75 million investment in this, what I consider to be infrastructure for the research community going forward, it's now more than $150 million investment over the next several years, because we've brought this partnership together between NVIDIA and NSF and AI2. And so I think that we need to be thinking about, and by the way, folks come at me these days from the Hill and elsewhere saying, industry's investing billions, trillions of dollars in AI. What's the role for NSF going forward? And I think this notion of how do we think about open models? How do we think about the explainability and the transparency of what's happening in the models? That is a sweet spot for federally funded academic research, in my view, just given where we see industry
Please
investment.
please tell them that we are all building on Quen. We're all building on Chinese models because we don't have a Western open frontier model. I mean, so there better be a point for the government or everything will be built on a Chinese model, which, you know, might concern some. By the way, I don't like all the anti-China stuff because, quite frankly, many of my mentees who are like my children are in China. But I do know it is a way of getting bipartisan support.
So I would just encourage, I can't be there today, but I would just encourage as the day progresses for everyone in this room, like we have some of the foremost thought leaders in these spaces today, to roll up sleeves and really engage on this and these related issues, because I would love, you know, I think we would love to understand what you're thinking so we can shape our investments accordingly as we go forward.
Great. So I think we're at time. I think we, you know, touched on some really interesting points there, including, you know, openness as opposed to secrecy. I think PR and awareness, and then I think per Erwin's point, deeply at the root of all of this, the need for education across the whole society, right? We need educated citizenry. I think that's a role we can certainly play in the academic world, and will continue to be important, I think, because of that. So let's thank the panel. Great job. Thank you. Thank you for joining remotely. We're going to go eat lunch. I'm sorry that we're not able to offer you one. Hope you feel better, David, and nice to see you, Erwin.
Yeah, thanks for joining.
Yeah, thank you so much.
Thanks.
All right, so it's lunchtime, and you can follow people who have Open Frontier signs to the lunchroom, which is, I think, far away from here.
Nice.
And we won't be coming back into Awesome.
Everybody take your seats.
5 minutes, 3 minutes.
2 minutes.
Your seats, 2 minutes. We're going to start the next panel in 2 minutes. Now. Stop talking. Go sit down. Thank you. Next up, we have our panel hosted by Dave Patterson, and he will be introducing the guests on the panel. So I'll just hand it over to Dave, who spent 40 years at Berkeley and invented Risk, and you've heard all the great things about Dave, our Turing Award winner. So he'll take over from here.
Okay, thanks. What? Yeah, everybody come take a seat. That's good. All right, we're going to, this is not, despite the age of some of the panels, this is not a nostalgia session. This is going to be an advice session. These are people who have built systems that have stood the test of time. Many of us use them still today, and we're trying to pass along the great advice from their great experience and how to make AI successful. So we're going to start off with Vint Cerf. Vint Cerf is one of the fathers of the internet and co-designer of TCP/IP. The early internet showed that open protocols, interoperability, and permissionless building are not abstractions, but they're design choices that let technical systems become durable public infrastructure. I've known Vint since we were both graduate students at UCLA in the 70s. He was a couple of years ahead of me. One of the things I remember about Vint, Donald Knuth, who even right then, this was in the 70s, had just produced his book, The Art of Computer Programming, and so he was already kind of a god of CS. And he wrote a paper referencing Vint's master's thesis, and Knuth thought it was a PhD thesis. And I think all the grad students thought that was a pretty good sign for Vint's future. You know, when I was honored to win a Turing Award, and you kind of expect when you win a Turing Award, when you see your kind of grad students, your cohort, that you were the most successful. Given that Vint is the father of the internet, he is more famous than I am. And I have made peace with that. Okay, so we're going to start off, we'll do the introductions one at a time, and everybody will do the same question. We're going to save time for audience questions, for sure. So Vint, what did you think was going to be the most important issue before you built basically the foundations of the internet, and what, in retrospect, after the system became widely used, turned out to be the most important issue?
You know, originally I sweated blood to figure out how to take an internet packet and fragment it in such a way that if it was split up into pieces and transmitted across the internet over multiple paths and then got reassembled at the destinations, I sweated the design of that capability. I was worried that some of the intervening networks couldn't carry a whole packet that was generated at the beginning and had to break it up. And so we worked really hard to make this fragmentation work and everything else. Well, an RFC got issued some years later saying fragmentation considered harmful, and we just pulled my hand. So it was really painful because I remember working very hard to get that to work. The thing that turned out to be extremely important was that the original protocol was called TCP, and it was the only one, and its job was to make sure everything got there in the right order. And retransmissions would happen, duplicates would be filtered out, and everything else. Well, somewhere around 5 years into the program, I got persuaded by some of my colleagues that I was wrong, that reliability wasn't the only important metric, and that low latency was critical for things like packet voice and, oh, by the way, radar. You know, you don't want to know where the missile was. You want to know where it is. And if you lose a couple of radar trace signals, it doesn't matter. Same with packet voice and packet video. There's more voice coming, there's more video coming. If your audio gets garbled, you just say that again, I didn't hear you. The important thing was low latency. Otherwise, you started stomping on each other. If you've ever talked over a double satellite hop, you know how easy it is to think that the other guy has stopped talking, but actually the packets are in flight. And you say something, and then the packet shows up, and the other guy is saying something on top of you. So much for my intuition, you know, about important design principles.
Thanks. To my left is François Chollet. He is an AI researcher best known for contributions that shape how the field builds and how it measures itself. In 2015, he created Keras, a deep learning library that made neural networks accessible, modular, and teachable. It became the high-level API at the center of TensorFlow and is now used by thousands of companies with more than 64,000 GitHub stars, and it comes along with a companion book, Deep Learning with Python, that trained a generation of practitioners. Bearing from his native France, he's a real Renaissance man. He both does art, like paintings, and composes music, and doesn't use AI to do it. So Francois, the same question for you. What did you think before you built the system was going to be a big issue, and what in retrospect did it turn to be afterwards if it was different?
Well, when I first designed Keras, I was doing it with in mind, like the user person I had in mind was a deep learning researcher at the time. And the biggest problem that people faced in deep learning research back then was experiment velocity. The frameworks, the tools we had available were very low level and very difficult to use, like tools like Theano, for instance. And so my goal was to speed up research velocity, to make it really fast, easy, effortless to set up experiments. And so I thought the most important thing with UX was to find the right API design, the right abstractions to mirror the mental models of practitioners, of researchers, and reduce cognitive load. And for a while, it was true. Like for a while, it was kind of like UX was the missing ingredient to make deep learning like broadly accessible and kickstart the rise of deep learning as an engineering field, like move it out of the lab and into companies. But then very quickly, APIs and frameworks just stopped being the most important thing. The most important thing as the field started to mature was not how to let people train a small model on their own data. It was how to give people access to pre-trained models, how to let people download existing checkpoints and repurpose them to new workflows. And so we launched Keras applications in 2016, so actually very early, to let people reuse pre-trained models in computer vision. And then Hugging Face, after a few years,
around like 2019, 2020, kind of like took over the space. And we ended up integrating with Hugging Face. But we went from a paradigm where frameworks mattered to a paradigm where models were the only thing that mattered.
Thanks. John Ousterhout is a computer scientist, software designer, and creator of ECAD tools like Magic that those of us at Berkeley used to do 4 generations of RISC machines in the 1980s, and then he did Tickle-TK in the 1990s. He's got decades of work in across operating systems, distributed systems, and software complexity. It's amazing that Magic, this software that he hasn't touched in decades, and Tickle-TK are still widely used today in the ECAD industry. I heard somebody making an argument a week ago where they said, no, we're going to go back and keep using Tickle-TK as opposed to another scripting system. And his work has shaped generations. And his book that he wrote on his own, A Philosophy of Software Design, is a bestseller that sells thousands of copies a month, which is amazing for academic. How many people know that book? Yeah, it's apparently AI is giving a big boost as people using the book to train AI systems now. John is one of my best and oldest friends. He and his wife Rita really took the underrepresentation of women in computer science very seriously. They have 2 daughters, Kay and Amy. Both got their PhDs in computer science in computer systems, one from Berkeley and one from MIT, and both of them are now assistant professors of computer science, one at UC Berkeley and one at UC San Diego. And I don't think I've ever heard the phrase, the apple doesn't fall far from the tree, more appropriately defined. A better example of that. John, go ahead. Your question for whatever system you want to talk about of your many systems, what you thought before and what it turned out later.
Well, first of all, I just want to say we decided to solve the diversity problem the old-fashioned way. So for your question, I thought about it with respect to my systems, and actually I had trouble coming up with a good answer because it seemed like, at least from a technical standpoint, the things we thought were issues at the beginning seemed to stay that way through the project. Now, maybe I've just selectively forgotten the surprises and changes along the way. But so I struggled with that, so I decided to pivot slightly and ask myself a slightly different question. So the question I decided to ask is there something that repeatedly over and over explained either the success or failure of my projects? And is there something that explained surprises when there were surprises? And for that, the answer, actually, I have a very simple answer. And the answer is market size. It's all about the size of the market. That is, if you take the results of your work, which you've worked on very hard, and you put it in front of people and you explain to them how it works and the benefits, will they adopt it? And how many people will adopt it? And how hard is it to get them to adopt it? And that, over and over again, explained both success and failure of my projects. And I've had 2 observations about that. One is, I don't believe you can create a market. Either it exists or it doesn't exist. Now, maybe there are examples where people have been able to somehow create markets that didn't exist, but if you can, it's extremely difficult and extremely expensive. But in general, if the market ain't there, you're not going to succeed. So, for example, in a startup, if you need to hire a really good VP of marketing, your startup's in trouble. First sign of startup is when the VCs say, we need to hire a really great VP of marketing. Sadly, both of my startups needed really good VPs of marketing. But I'll bet you'll see that, I bet Databricks didn't do much marketing.
Speaking as an investor in some of your companies, I'm sad as well.
Tesla didn't do much marketing. Google didn't do much marketing. The second thing about the market is, unfortunately, it's very hard to predict whether the market is there or not. You sort of have to build it and try. Particularly if you're working in a really new area, there's just no way to predict ahead of time. Like with Tickle, I thought when I started work on it, I thought the worldwide market for Tickle was one person, me. And then it ended up that 8 years later, millions of people were using it. And there have been other cases where I've built systems that I thought would be really good, and there just wasn't that much of a market for them. So in some ways, it's kind of disempowering, and that there's this thing that determines our success or failure that we have very little control over and we can't predict. But that's just been a fact of life.
But you said 2 things. You said size of the market, but you also said how easy it is to explain it to them. You didn't give that much emphasis there.
Well, sort of, see, the market may not exist when you start because nobody knows about your product. Like cell phones, for example, 1970s, there was no market for cell phones. But once they got out there and they were available and people could see what they could do for them, then bingo, they took off. So that has to do with, can you easily explain and can people easily appreciate the value once you've explained it to them?
Okay, next up is Matei Zaharia, the creator of Apache Spark, co-founder and CTO of Databricks, and a professor of computer science at UC Berkeley. In fact, there's kind of a big 3 or 4 computer science departments. Matei is the only person I know who's been faculty member at all of them. He was a faculty member at MIT and at Stanford and at Berkeley. He created Spark during 2009 during his PhD at Berkeley. Spark has become a standard engine for data analytics, machine learning, streaming, AI infrastructure, with thousands of contributors and reportedly used by 80% of the Fortune 500. Last year it was recognized, or I guess this year it was recognized by the ACM Prize in Computing, which is the second highest award in ACM. Matei brings this perspective of someone who turned a research prototype into a durable, widely adopted open source infrastructure while a PhD student. I remember when we started the RAD Lab at UC Berkeley when Matei came his first year. And part of being radical was to have a radical space plan. The faculty and students were all in the same place. We had meeting rooms and worked interdisciplinary with people, disciplines all working for a common goal. I was struck that in the very first year, these new graduate students, Matei and Andy Konwinski, did a research project that was so interesting, they were invited to give a talk at Carnegie Mellon. I don't know if the rest of us who are graduate students remember their first year of graduate school, but mine was nothing like that at all. So I thought, man, this radical space is just working incredibly well. But now that I've followed their meteoric careers, maybe it wasn't so much the space as it was the people that got put into the space. Okay, Matei, your turn. Kind of before and after for your things.
I think the space helped. Actually, interestingly, in my cube when I started was Percy Liang, who was like right next to me. So that's one of the things that got me to work on systems for machine learning. So it was really cool to have everyone there together. And also, despite that, as you said, I wasn't able to hold a steady job.
Did you get fired twice?
I don't know. Won't comment. But so with Spark, I would say it's really hard, looking back to think about what was different, what were we thinking that's kind of the same. But I would say at the beginning, we were maybe really focused on performance for certain use cases. And then we got very excited about composability. So we realized that, even though it's fun to build high performance, like say machine learning algorithms or something, most people don't want to build them. They want to use one that someone else wrote and stick it into a program and compose it with lots of other operators and reliably and efficiently get a result. So we actually changed the focus quite a bit on composability. And in the sort of data center scale computing space, I think nothing before Spark actually allowed you to import libraries and compose them in a reasonable way. Like in MapReduce, the types were file types. They weren't types in a programming language. So I think that's one of the things that helped, that we learned.
Okay, I'm just going to open this up. So once we started late, so when do we stop? Is it 4:30? Okay. All right, I'll stop at 4:30 unless somebody tells me otherwise. Okay, so for whoever wants to, I'll throw this open question. I think it'll work for Vint. I don't know if it'll work for others. Was the competition to your system proprietary, and how did being open help or hurt adoption? Well, I think, why don't you start?
Thank you. That's a really good question. I wonder if I could just make a comment about one of two of the things that we heard just a few minutes ago. The reference to market is absolutely spot on. And I thank you for drawing attention to that. I would add the word addressable market because there sometimes are big markets, but you might not be able to address all of it. And people who run around saying, well, if I get 2% of this giant world market, everything will be wonderful. But it isn't clear that you can always do that. There was mention of cell phone in 1970s in the same sentence, and I need to remind everybody that the first handheld mobile phone doesn't go into operation until 1983. Marty Cooper did that with Motorola, although he did start the design work in 1973, ironically the same year that Bob Kahn and I started working on the internet. Coming back to the question that you asked, which I need to...
Competition was proprietary or?
Yeah, right, yes. Okay,
how did being open help or hurt?
We had a very peculiar competition associated with internet. First of all, before or contemporary with the internet's development, a guy named Larry Roberts, who had run the Information Processing Techniques Office at ARPA and led the development of the ARPANET, predecessor to the internet, went off to start a company called Telenet, which was from spun out of Bolt, Beranek, and Newman, who had built the ARPANET. And he didn't want to have anything to do with datagrams. He decided that the only thing he could sell in the packet switching space was virtual circuits, because people were accustomed to buying circuits and he thought they would buy virtual circuits. So he went off to the International Telecommunications Union and developed a standard called X25 and X75. That was in operation in the late 1970s. So that was a standard that was commercially available, and we were in competition with that. Meanwhile, in 1978, after 5 years of work on the internet design, the Europeans decided that they didn't like a military system, and they went off to develop what was called Open Systems Interconnection, which was in direct competition with the internet design, both of which were open source, or at least open spec. Meanwhile, the proprietary companies, IBM had SNA, and Digital had DECnet, and HP had DS, the distributed systems or something. And they were commercial systems, proprietary systems, and they were selling really hard, saying, you know, you really don't want all those other brands of computers. Just use our software and our networking and hook our brand of computer together and you'll be happy. So we were competing not only with open spec systems, but we were also competing with proprietary systems. And the irony of all that is that while I was still at ARPA running the internet program, I had gone to the laboratories at IBM and Digital Equipment Corporation and Hewlett Packard when they had research laboratories and asked if they were interested in participating in the internet development. And they said yes. So their laboratories implemented TCP/IP, even though the sales teams didn't know a thing about it. And it was really amusing to watch their stories about the IBM sales guys selling SNA really hard. And the customer says, what about this TCP/IP thing? And the sales guy says, what's that? And the engineer that they brought to answer technical questions says, oh, I have it running in the lab. And everything fell apart and everybody adopted TCP/IP.
So the success is due to IBM sales people, okay, and their engineers. Did anybody else want to take that one? Did you have a proprietary competition?
I'll just say for me, the competition has always been other open source stuff. And I think that's because I tend to work in low-level system infrastructure where open source is much more prevalent. I actually wanted to follow up on a comment Matei made, though, about the importance of allowing composability of the various scripts for Spark. And that relates to another thing. I wanted to mention a comment that Jan Stoica mentioned a couple of weeks ago when I asked him, how did he manage to have so many incredibly successful projects? And he said, one of the key things he did was to try and build communities around them. And actually, I was reminded of that when, Matei, you made your comment, because I think what really happened as part of this then was that a community developed where people created the various Spark modules that other people could use.
Yeah, that's exactly.
And I have to say, for myself, one of my failures, I have not been as successful at developing communities. And certainly with Tickle and TK, for example, we weren't as good at putting together sort of open source contributed libraries of things as Perl and Python did. And ultimately, I think those other languages ended up having a lot of their success because they did that better than we did. So I just want to reiterate, I think Jan is right about this idea of forming communities.
Okay, so find an addressable market and build a community around it.
Now, to some degree, if you have the market big enough, the community will form on its own. The market will just form the community. You don't have to. But so I think to some degree, those two things go together.
But in the early days, might be a good strategy, is to think about.
But there are probably ways you can stimulate the formation of the community.
Okay, that kind of answered one of the questions. Anybody else want to talk about proprietary? Okay, or other people's comments? Okay. Let me just go ahead. What advice do you have to this next gen? Well, some of you aren't next generation. For those of us who have white hair or should have white hair, if we could grow hair.
Once had white hair.
What advice do we have for the next generation on how to have long-term impact? How about, okay, Vint raised his hand.
I have one piece of advice. If you want to do something big, get help, especially from people who are smarter than you are. That's all of my success as a consequence of being willing to do that.
Okay, John?
My advice is very out of fashion today. We're in a world where speed and granularity are very fashionable. Do lots of things very quickly, throw out little bits and pieces. I believe what has made me successful is thinking very deeply, focusing on a very small number of things, spending a fairly long time, and trying to think fairly deeply about it. And I would just like to plant one thought in your mind about this. There's not a lot of room on a tombstone. Let me explain that. When you die,
bring up mortality.
When you die, they are not going to etch 300 citations into your tombstone. If you're lucky, you'll be remembered for one thing in your career. And if you are really, really good, you might be remembered for 2 or 3 things. And so I would say, optimize your career for that one really, really great thing, rather than just trying to throw out lots of quick and dirty papers to meet the next conference deadline.
I guess I'll put myself in this group. I could have white hair if I wanted to have white hair. Yeah, I mean, I still remember, you know, even though this is my 50th year in the field, I still remember joining Berkeley as an assistant professor and asked what did Berkeley want. And I was particularly worried about co-authoring papers with senior faculty, and did I have to have my own, was that a bad thing, or did I have to be the first author, and what about research funding and stuff like that? And whoever it was who told me advice, and I think it was the department chair, who was Erwin Berlekamp, who was a kind of a genius. He said, Berkeley cares about impact. It does co-author with senior paper, I don't care. Impact, and that's all that matters. And I love that advice. It's very altruistic advice, and I loved it. And that's what's guided my career. And when we see these indirect measures of success, like citation counts, and particularly the H-index, which is just the terrible invention. You know, I really like Google Scholar, but it has enabled some really bad measures. The H-index of 100 means you have at least 100 papers with 100 citations. Clearly, one paper with 10,000 citations is much more important. So my career was aimed about trying to have impact, that I got the advice from early on. And I realized pretty quickly, you know, most people don't have impact, and most projects don't have impact. So that's why we did these 5-year projects. It's like, well, it's no fault if it doesn't work. Most of them don't work, and they only count home runs. They only count the winners. So why don't you give yourselves more at-bats, and we'll do more 5-year projects, and especially in a fast-changing field like ours, how working on something 20 years. So I would encourage you to do that. Ousterhout kids me about giving advice, but I give so much advice, I actually have written articles on advice. But one of those is one of the pieces of advice is 2,000 years old, which is fortune favors the bold. It's really hard to tell when you're young whether to take risks or not. But the advice that goes back to Homer 2,000 years ago is fortune favors the bold. Take the risk. And Helen Keller has kind of a corollary of that. And it's like, even the meek get caught, right? It's very hard to tell what the safe path is. You know, you think you're on the safe path. I remember I visited some some university and talked to some assistant professor, and he told me, this is what I'm doing is pretty boring, but it's a safe path to get tenure. And then I went and talked to his department chair, and he said, yeah, I'm really disappointed in what this guy's doing. So because he was just doing kind of mundane stuff where he could get a bunch of papers. But yeah, so fortune favors the bold. Vint has his hand up.
Let Vince go, then I want to follow up on your comment about paper counts.
Okay, go ahead, Vint.
I was just going to say that when you're young, you should take the high-risk things because you've got plenty of time to recover if it doesn't work out.
So
when you're old, you can take the high risk because you have nothing to lose. So.
Okay. When you're young, you have plenty of time to recover. When you're old, you have nothing to lose.
So I want to talk about the paper counts. Actually, I think paper counts should be included in our evaluation of people. Actually, should be included. It's just that it goes in the denominator. So the way to rate somebody, I say, is you take impact in the numerator and paper count in the denominator. Because surely if two people have the same impact and one person did it in one paper and the other person had to write 100 papers to do it, who do you think is a better computer scientist? The person that did it in one paper. So just remember, paper count goes in the denominator.
Awards divided by paper count. Okay, Andy, we're working on an impact index. Did other people have comments here? Yeah, Francois.
One thing to add to yours. So I really love your advice to focus on impact, optimize for impact. One piece of advice from me is that your impact is not just measured by the code you write, or nowadays the code you generate, and the artifacts you ship. It's also measured by everything you let other people build, right? And so my advice is find what platforms you can build, find what's sort of like low-level or mid-level layers of abstraction you can create that let other people have an impact, because their impact adds to your impact.
I like that. You want to add anything about impact, Matei?
Yeah, well, I liked all the previous advice. Collaborate with people, do long-term things, take time to think. Everyone is like right now very hyperactive and, not doing long-term things because it's so easy to chase the short-term ones. The only other one I'd add is, at least in some of these like platform things, it's like really try to understand the users or be a potential user or whatever of the thing you're doing. I think that's hard for a lot of people, but like at least go talk to them, have someone.
Talk to users?
Yeah, or have someone try to use your thing, see where they're struggling, because they'll be different from you. Like the whole point is you're an expert on something, they don't want to be, but they still want to do that thing. That's why you're writing software for them.
Yeah, I've got the opportunity to remember grad students saying this over the years, but yeah, another generations before, you're not a grad student, sorry. In my mind, you once were a grad student. Other people who once were grad students said the biggest learning experience a software developer can have is watching someone use their system. and that's pretty hard, especially pretty easy today to do, would be to put your system out there to use it and watch real people use it and see what you learn. Okay, so go ahead, Vint.
It's Vint. I wanted to make two observations. One about long-term. All of my projects have tended to take a hell of a long time. The internet started in 1973 and preceded by ARPANET, so it's still going. The interplanetary internet work started in 1998, and it's still going. But the other thing I wanted to point out is that a lot of the successes come from enabling technologies, whether it's a platform or some other fundamental element that others can build on. And the composability point that was made earlier is an integral to that. So we should, if you really want to look for impact, think about things that enable other people to do things that they want to do.
Yeah, it's similar to what Francois said. Okay, we are novelly on our panel session going to open the floor to questions from the audience. And the key is to get the first question. And once we get the first question, more come. Okay, am I going to have to call on somebody? Andy. He's got a microphone.
I can't prepare. I'm going to also run the microphone for other questions. Vint, I read, I think on Wikipedia, that in 1974, the internet was offered for sale to AT&T. Is that apocryphal?
No, it was not offered for sale because it wasn't something you could sell. Nobody owned it. However, AT&T was invited to participate in it, and they had no interest in it whatsoever. They said it wasn't going to work. In fact, they didn't think packet switching made any sense. In 1972, in I think October, we demonstrated the ARPANET in Washington, D.C. at the Hilton Hotel. And AT&T showed up with a contingent of 4 or 5 people. And Bob Metcalf, who, famous for the Ethernet, was the guy who led them through a demonstration of the utility of the ARPANET applications you could use. And partway through the demo, the imp died. And of course, the AT&T guys got a big smile on their face and they walked off saying, see, we said it would never work.
It proves their point. Okay, there's a hand back here somewhere. Was there a hand? Yeah. Did I make it up? Okay.
Hi, folks. Fernando Perez here from Berkeley.
Fernando, by the clock.
We're here. Hi. So all of you have talked kind of about the value and impact of doing your work in the open and use many of your tools. And I've been building things also in the open for 25 years now, but I'm very concerned about the next 10 years because I think, ironically, open source approaches in one sense have won, in the sense that we don't have to argue anymore for the value of open source tools in industry and research everywhere. They're kind of pervasive. But at the same time, the dynamics of building sustainable communities, of participating in these communities, are kind of getting very fragmented right now because a lot of the incentive mechanisms around H-index, around very rapid publishing, around industry capture of specific tools are making some of what the processes that we had in the last 2 or 3 decades harder to maintain. And we're seeing that strain in multiple open source communities. And the acceleration of rapid software development with AI is adding to that tension. It's both an opportunity, but it's adding to that tension. And so I'd love to hear thoughts on how do we maintain the value of open source communities where ultimately knowledge is captured in these artifacts. What Jan was saying earlier, the value of these artifacts is that they capture the knowledge and practices of a community. And that takes time to build. And I'm very worried about sort of the next 5 or 10 years in that regard.
One of you guys who ship open source software, are you seeing these changes? Matei? Okay.
I think one part of it is for sure now you got a lot more patches, and many of them are AI generated. So like I know for Apache Spark, it's a huge number of patches coming in. Also many like...
So like compared to a couple of years ago?
Yeah, and also worse is like many that are, security reports, but they're not actually valid. That was happening before too. Someone was running a tool that said, oh, I found something. For Spark, it's like, hey, Spark lets you execute user code on a remote machine. Yes, that's the point of it. That's exactly what it's supposed to do. You can upload like a jar file or a Python script and it'll execute. But there's so many of these. So I think, to maintain these is tricky. I do think things will settle down.
Let's see if I can understand, despite my age. So it's, given its software, the open source software ecosystem is based on conscientious people finding bugs and patches. The problem is that people are using AI to try and get points in the open source community.
Yeah, or maybe they think it's actually helpful, but it places, the bottleneck is reviewing, right? So it places a lot of load on the maintainers and reviewers.
So given these are largely volunteers doing it, and so just like conferences are getting swamped by papers, open source systems are getting swamped by stupid patches.
Yeah, exactly. Yeah. I'm hopeful that we'll figure out a better dynamic, but it's tricky. And I think part of the dynamic will be changing the design of software itself, so there are more isolated modules or something. So like if you contribute a connector, it's not going to bring down the whole system if there's a bug in there. But that's the issue I've been seeing.
Vint has hand raised.
Just an observation about open source. My impression is that a lot of the useful open source sometimes doesn't get much support. It may be 1 or 2 people and that's it. And so open source, as good as it is, sometimes suffers because it isn't properly maintained. Your point about the influx of patches is even more worrisome, especially if it's a malicious patch that you don't catch and somehow gets in. So open source has some weaknesses associated with it that we should probably be worried about. This is not an argument that says proprietary code is any better necessarily.
Okay.
So Arun Rao on the Neutron team. Question about, fortune favors the bold, and often it's like new ideas reinvented. What do you think people are missing in the current AI research space right now? So if you think of language models, it's just the evolution of ELIZA, ALICE, and Grams and RNNs to the current transformer architectures. What are the other side areas that even within the field of AI that you think people are not looking at enough at?
Francois, you want to take a shot at that?
Yeah, beyond, a lot of the discussions I've been hearing today, there's this baseline assumption that everything in AI is already figured out, that the current architectures are the only thing there is, and that AI is now just an engineering problem. You just need, data centers, you just need resources, that's it. You don't need new ideas. And I kind of disagree with that. I think you need new ideas. I think deep learning worked because it's the first thing we built that really scaled. But it's not the only thing that could scale. And it's not even the best thing to scale. So it ended up taking over everything because basically it gave you access to this button you could press where it deducts some money from a bank account, but it makes the model a bit better. Like you can basically spend money on data and compute to make models better in a very predictable way, and basically indefinitely. There are no bottlenecks. And this is why it worked, because when everybody discovered this fact, it just kept mashing the button, But it doesn't mean it's the right thing to scale. And there are many, many other ideas that could scale to the same extent. I'm very interested in program synthesis in particular, which is in many ways similar to deep learning, but with the idea that instead of training vector functions via gradient descent, you're going to synthesize tiny symbolic programs via search, via some kind of search mechanism. I'm very interested in genetic algorithms as well. In general, I think there are many different classes of algorithms that could have scaled to the same extent, but we just didn't look into them because the first thing that worked was deep learning, and then that's what we ran with. But it doesn't mean it's the only thing that could work.
Go ahead, you guys, Matei and John.
You want to? One thing I'll mention is just reliability and security. So I think with all the current approaches, we throw in a lot of scale, we do all our post-training, we hope it works, but we can't really guarantee it. And actually, that's the thing that I think will get worse with lots of agents around. They'll just create more threats. So I think that's a great area to work on in some fashion. I don't know the best way, but it's very complementary to what's going on.
So I'm not heavily involved enough in AI applications to make specific suggestions, but I want to point out a historical trend, which is that if you look back over time, the first player to strike it rich in a field almost never ends up being the final winner in the field, if you look back. Take the spreadsheet. So VisiCalc by Bricklin and the person came out, I forget, in the late 70s. That was superseded by Lotus 123, which was eventually superseded by Excel, which became sort of the long-term winner. Look at search engines. So Google was not the first search engine, or the second, or the third, or the 10th. It was, there'd been many search engines before Google came along, and so on. If you look at every field, the first ones are typically not the ultimate winners. So don't worry that maybe somehow things are settled now, that the big players that are out there today are going to own this market forever. They almost certainly will not. There's almost certainly going to be some new person with some other ideas to do even better that will take over.
Yeah, I'll add a comment too. Because I work at Google, so I work near AI people. And my friend Clef Young has an analogy. He knows history pretty well. Let's think about steam engines. In the beginning, James Watt came along. He made it like 3 times better. But this was before we had the 3 laws of thermodynamics. And it went from like 0.5% to 2%. After we had the 3 laws of thermodynamics, which took almost another 100 years, steam engines ran at 40% efficiency from the fuel that was put in once we understood. So I'm pretty sure we're in the early days before the laws of AI. When you ask an AI searcher they did this thing, why does it work? And the answer was, because it works. We don't understand why it works, and that's where we are. So it's a remarkable time. This transformer architecture, like you said, has the scalability. You put 10 times as much resources in, it gets a little bit better, and you can keep doing that. But I have to say, AI as a phrase has been around 80 years, and this is the first one that's really worked, right? So it's not like everything else you're going to try is going to work. But we have an existence proof that works. It's incredibly expensive, but also it changes fast. We just published a paper about the Google workloads. And like 10 years ago, multi-layer perceptrons dominated everything that Google did in its production workload. And now they're about 10%. And transformers didn't exist 10 years ago, and now they're 75%. So it's a field that very rapidly can change when an idea comes along. But if you look at the history, it's really hard to look at that and say, wow, nothing could possibly replace transformer when things have been changed all the time. So I think, I wouldn't be, these don't feel at all like the end days, and that there's nothing left to discover or anything like that. I assume in 10 or 20 years we'll look back and see, wow, I can't believe we used to do it so stupidly as we did it back in 2026. Okay,
so,
go ahead. Vint.
I'm sorry, could I just jump in? Your comment about this not being the end game, but it's at the beginning. Today, if you talk to the physicists, they'll tell you that anybody that claims to understand quantum physics is lying. And I think that something is true about AI right now. People who claim they understand what the hell is actually going on in these transformers might actually be lying. I would also argue that we're seeing some alternative paths being explored, world models being an example of that. So I agree with you and others on the panel that we're in very early days, despite the fact that this all starts in 1956. It's not quite 80 years ago. But the term artificial intelligence got introduced at the Dartmouth meeting.
Isn't that 80 years?
It's by John McCarthy, if I'm remembering his.
Okay, more audience questions.
Hi, Sharon Goldman, formerly at Fortune magazine. I'm a journalist now publishing Ground Level AI. I'm curious, based on everything you just said, what your feelings have been like observing the discourse around Anthropic's fable and mythos of the U.S. government over the past few weeks.
Anybody want to take? I don't know anything about this stuff, so Matei or
not qualified to comment.
Yeah. The fact that she's a journalist.
Ben has his hand up. I never walk away from an open microphone. Look, what we're discovering is that these systems are actually damn good, not only at writing software, but at discovering bugs and trying to fix them. Of course, that exposure vulnerability is also hazardous because some people will abuse it. I think in the long run, the capacity of these systems to both discover problems and to help solve them will turn out to be beneficial. We just have to exercise them in the right way.
Okay, other questions here? Okay, go ahead. I recognize that guy, Braden.
Thanks. Yeah, so I'm Braden Hancock. I work at Laude, Laude Institute. So you've all worked with different paradigms that I'd say have had different moments at the top of the hype cycle, right? Where there's a lot very active research, and then maybe attention will shift to other areas. All these areas, I think, continue to see investment, but at varying levels. We've said here today, you've mentioned you feel like we're early innings for AI, and I certainly agree. But I'm curious, with your perspective that you all have on projects that have peaked at different times, whereas it feels like we're in some ways still ascending on AI. What has indicated to you before that we're no longer in early innings, or that a field is maturing, or that it's kind of cooling down and settling into a more robust, long-term, stable situation?
Boy, I'd say in computer architecture was what I know. I guess when there's absolutely no interest by the companies in new ideas, more or less. You think you've got a great idea, and they're happy They know how to make the next thing. They're making lots of money. They're not interested. When they're in trouble, then when things are hard, then they start looking around. Now, there's a lot of excitement about AI, but the costs are astronomical. It's the 4 hyperscalers have announced in 2026 they're going to invest $730 billion in capital expenses for AI, for data centers and hardware. They're borrowing money against the future to invest this year. This is almost half of all the capital expenditures of the S&P 500 are those 4 companies for this year. So this is extraordinarily expensive. If somebody had a model that was 10 times more efficient, people would beat a path to your door. So these are times where tremendous excitement and investment. This is one of the times where if you've got a good idea, they're interested. It's hard to believe right now. How long will it be before AI reaches the maturity state where you've got some great idea that's risky but has high potential that nobody's interested in that? It's kind of hard for me to imagine when that's going to be, but it's certainly not now.
Can I react to that?
Yeah, go ahead.
So I'll tell you when we can tell for sure that AI is maturing and the paradigm we have is here to stay. I think learning is, you can characterize it by a conversion ratio between the information you have about something and the scope of things you can do with this information. And if it's conversion ratio, then it starts to plateau when you're near optimal. There should be some optimality point. And I believe current deep learning techniques, so basically scaling up large transformers trained on large text corpuses, that approach is about 4 to 5 orders of magnitude away from optimality from a data efficiency standpoint, and about 5 to 6 on an inference compute standpoint. And you will be able to tell that the field of AI has matured when we are within 10x of optimality. And we still have at least 3 to 4 orders of magnitude to go.
It's Vint. Just a question along those lines. Distillation appears to be quite effective, and we're seeing instances of that serving well with smaller models performing almost as well as the larger ones. Is that something we should?
With the previous model more quickly. But the problem is that you still had to expend all these resources to produce the training corpus in the first place. So I think the efficiency ratio should be computed from the raw data, which is out there in the world, like text data on the web, for instance.
Good point.
Other questions? Andy.
I have another question. The stack that we saw emerge around the internet is very inspiring to me as an example where technology put forward a common infrastructure that brought that enabled a paradigm that followed after it to be very productive. Like I like to think that, maybe immeasurable success in terms of the use cases enabled by the invention of the internet. AI feels similar, but the open spec we talk about open weight models. We don't as often talk about open specs with the age of AI, and the folks doing research aren't, by and large, using a distribution or a stack that looks similar to, like Marin and Nematron aren't using a stack that looks very similar per se. Is there a parallel to be made? Is like a thesis here is at this this one-day meeting that we're kicking off is that there can be an infra commons for AI. Is it possible that it is a software stack, or is it going to be in the data, or is it going to be in the evals, or how is it different? How is it the same?
Could I make an observation about this? A very good question. In the internet case, the layered architecture was really helpful because you could extend within a layer by adding new protocols, or you could add a new layer like Tim Berners-Lee did with HTTP. I don't know whether in the AI world there is something similar in character that allows this vertical and horizontal expansion and interfaces that are stable so that you can mess around with implementations inside of a given layer without messing everything up on either side because you maintain the continuity of the interfaces.
Yeah, for me, I think the part that would be really interesting is some form to reuse data and environments so that you can mix and match and have your own training recipe. So I think the academic community at least is building lots of benchmarks, but they don't build that many like pre-training data sets or post-training environments. And there's very little research on how to stably mix them. Like if I want to add a capability to my model, how do I make sure it doesn't lose all the other stuff it has? But these are the things that would get us to a more composable state, like what Vint was talking about, which is a lot easier with software than with machine learning. And then if you have that, there'll be a lot of incentives for the community to do things, right? Like someone will do just a data set that like does some kind of, special branch of math that like later gets into a model and is used to like prove some stuff. Someone will do just a data set for like some branch of chemistry, but we don't have that right now. So that could be, make machine learning more like software, basically.
Okay, I think what I wanted to do is, as part of this, the other story I wanted to tell about Vint Cerf is he's always been the best dressed computer scientist I've ever met. So I knew him in the 70s. In the 70s, I looked more like Andy than I look like, but my memory of Vint is that he came as a grad student with a shirt and tie in the 70s. I don't know if that's really true, but I think it might be true.
Is that true, Vint?
It absolutely is true. I even had a vest, and for some reason, I always wanted to stick out, and instead of having long hair and
everybody has long
my nose, I thought just dressing differently was one way to do it.
And then the other thing I wanted to say is in putting this panel together, I discovered Vint has been at Google more than 20 years, and he is retiring a week from today. And so I think we ought to give him a round of applause for a relatively good career. Okay, with that, we're going to finish. What? Oh.
One last question,
Okay.
because our next two speakers are getting themselves over.
Okay, I was going to turn the stage over early, but we'll stretch for you.
No, we're not stretching. We're just using our time efficiently to get more insight from luminaries. We're here discussing open science and its future. And a thing that came up in a lot of the breakouts and conversations I've heard around so far today is specifically around concentration of power and what it's like for a few frontier labs that have much more funding than the precedent and past paradigms required to be at the frontier. How that's changing, creating a difference in this paradigm compared to past ones. And then if you contrast it to how my interpretation of the internet decentralized and was this beacon of decentralization of power, at least that's kind of how I related to it as growing up. Do you have opinions, especially Vint? I'm curious, are you worried that this paradigm might play out differently? And I like to tell people that a few researchers can make a difference, like one person really standing up and being an inspiration and challenging or advocating for open specs, open protocols can make a difference. So that the parallel here being open infrastructure, open data, open spec, I guess, if we can figure it out.
This is actually a very thoughtful question, and thank you for asking it because it triggers an idea that I had not thought of before. In the case of internet, it only worked because it was going to be distributed to begin with. We knew that multiple parties had to build pieces of the internet wherever they were and then find a way to interconnect. And so we left the rules very open. We just said, if you can find somebody to connect to and you follow the rules of the protocols, it should work. The whole system was designed to be highly distributed with multiple parties offering service. the AI world has just reached the point where that might turn out to be a paradigm. The agentic model of AI with multiple agents from multiple sources interacting with each other is going to force a composability and a requirement for interoperability and standardization. I don't know exactly where that's going to end up, but we know about MCP, we know about A2A. I'm sure there'll be other developments coming, but it's the proliferation of agents which I think will have an impact on this collaborative element that showed up in the internet at the beginning, because that's the only way we could see how to build it.
Curious if Matei or Francois agree or disagree, or
yeah, I do see a bunch of that happening where all of these models have this natural language interface, and they're pretty good at, calling other tools and getting input that it may not be totally trusted and stuff. So now it's a lot easier to make an application using lots of sub-agents and have them talk to each other. So maybe in the future, I was saying like maybe a researcher would want to create a data set or RL environment for some capability, but maybe instead they just create an agent and they just say, hey, have your agent call mine if it sees a biology problem or whatever. Could happen. It seems less efficient, but maybe that's fine.
Well, my guess is that they will come up, these agents or the implementers of them will come up with efficient languages. Didn't I hear that there was a chat group of allowing only agents for AI systems to be part of them? They invented a language of their own and a religion and a few other things.
This sounds like an anti-Turing test, that somehow the computer can decide that there's a human there and cut them off.
But does this mean Matei, is there some kind of opportunity for a TCP/IP for agents, or have people already done that, or
is it just natural language?
That's what A2A might turn out to be.
Yeah, it's a good question. I think you could do better than what we have now, but yeah, people would argue it's just English or whatever, but yeah, it'll be interesting to see.
I don't think English is going to be the best choice. There's a flexibility in it, but there's ambiguity, and I think precision for inter-agent interaction is going to be very, very important. An agent really needs to be sure the other agent understands what it is that they just agreed to do together. And I think precision and vocabulary and well-defined terms might be forced on us in order to avoid the consequences of remember the old telephone game where you whispered in somebody's ear, and then by the time it got to 10 people away, the message was totally different. Imagine a bunch of agents talking to each other in natural language. That's kind of terrifying.
Okay, I think we should thank all the panelists, including the remote panelists. And we'll give up the stage for the next group.
All right, thank you so much. Okay, we're doing quick furniture swap out, removing 2 chairs, 3 chairs. Next up, we have Ali Ghodsi and Thomas Wolfe in a fireside chat, where we'll be hearing their perspectives on the frontier open research coming from 2 companies in the space that have history with open research in AI. Databricks and Hugging Face. Ali is the CEO of Databricks and a co-founder, and was a researcher in the AMP and RAD lab at the same generation as Matei and me, with Jan as advisor to all of us. And Thomas is the chief scientist and co-founder of Hugging Face. So this perspective that they're going to share with us hopefully can shed light more from the industry angle, and that's one of the key angles that we care about at the intersection here of academia, the industry, and sort of government/philanthropy that need to team up for this common AI infrastructure commons. So let's welcome Ali and Thomas. Ali and Thomas. All right, I'm going to go see where they're at. Oh, there they are. Welcome.
Hey, how are you?
Hey.
Okay. Well, thanks everyone for staying until the end. The end is actually not the least, but the most impressive, I think, in my opinion. Ali, who doesn't need any introduction, but I was still happy to discover when I was reading your biography that you actually spent a lot of time also in Europe, in Sweden, and you moved around. So you're not only in distributed system, but you also had a distributed life everywhere. Sure. So I think the interesting topic here will be, I would say, well, you cover a lot of super interesting things for this audience, I think, from open source, open research, to product, to building companies, to actually also having companies that transition from data to the AI world. You yourself are also a very rare breed of someone who has been both extremely technical, but also have this super deep product acumen, or like view of, I think, very strong opinion how the product should be built, which is what maybe today in AI world we call taste. So I think you have a strong taste, and we should learn a lot about that. Maybe for here we can start a bit about, can you tell us a little bit how basically Databricks went from, like how open source and open research led to building this company, and maybe tell us a little bit about the origin story.
Yeah, happy to. Yeah, Databricks would not have been possible without open source at all. So, you know, many companies, they raise money and then they're on this clock to get product market fit. And, you know, it's very stressful. And then they have VC money and the VCs are telling them, hey, you need to hit this revenue target and that revenue target. And, you know, you're falling short compared to that company over there. You know, they were by this time already at 1 million revenue and so on. We had time to, at Berkeley, really do research and build up many different projects. And actually the projects that we thought maybe would be the most successful, we had a project that was called Mesos. We actually thought that that's going to be the company that we eventually will commercialize. And it had great product market fit. And then we had actually this thing, Apache Spark, which became Databricks Foundation, was just actually like a demonstration on top of this Mesos thing. But Berkeley and open source and the open community and research gave us the opportunity to like test these ideas for several years. And we knew by the time we started the company that, okay, we were actually kind of wrong. The Mesos one maybe is not commercially as viable. The Spark one is much more viable. And already we kind of knew that it had really good product market fit when we started the company. So we started with product market fit. That would not have been possible without open source. So we already started with something that had product market fit, which is the thing that's super notoriously hard to do with any company, right? So that was the basic foundation. It still turned out it's really, really hard to go from that to making the open source project really take off all over the world so that, you know, everyone knows about it, and then also commercializing it. I have a fun story. I remember in 2014 or 15, so Databricks, you know, at that point was $500 million valuation company. We thought that, you know, everyone in the world knows Apache Spark. It's like super successful. So we went to a meeting at IBM, and there was an IBM executive that sat there, and he was typing on his keyboard with 2 fingers only. And we came in, and he looked at us, and we said, hey, have you heard of Apache Spark? Because we wanted to sell software. And he said, yeah. IBM developed that, and it was really, really good. And we said, well, no, actually, we did that. He said, well, IBM did really great stuff on a Spark, as far as I know. So it takes a long time before the whole world actually kind of knows. Like here in Silicon Valley, people might know that, okay, this is a great open source project, and it's on Hugging Face, and you can download it. Yeah. But it takes a long time before you really have awareness all over the planet, and then, you know, building a company around it. So there was still much left to do, but it would have been impossible without open source.
Yeah, that's a good point. That's actually something I say often to people who want to reproduce what we did at Hugging Face, which is building community takes more time than you think, and building awareness around your product. Do you think this is something that has changed still a little bit recently, like when we saw cursor adoption that can go really, really quick, for instance, for some of these products? Or do you think generally you should still take time to incubate these projects enough and give them enough time? I mean, some of the most recent, like for instance, OpenAI is another good example. They incubated kind of for several years before then the revenue really took off and the product market fit was found. Yeah. Do you think this is still something that I would say we should cultivate in the age of 2026, where everything has to be solved in 2 months because we think AGI is maybe going to come in September, so you actually have to...
Exactly, yeah. Well, I don't believe in that, so we can get into that if you want, the whole AGI superintelligence thing. But I think that for many things, the interface is much easier to learn. So, Apache Spark, you need to understand how the programming model was, and you have to adopt it. But for many of these things, you just need to speak English or another natural language, and it just works. So therefore, you see much faster adoption. But also, I think you get much faster to the ceiling. So previously, it might have taken like a 6-year journey to do that S-curve to get to saturation. Now, many companies get to that saturation within a year or 6 months. So it's good news and bad news, So it doesn't mean like it can continue. There's only so many people on the planet, and we've seen many of these things. Like there's been actually many startups that came and had amazing. I'm not going to name names, but they came and they grew insanely fast. One of the fastest they've seen in the history of computing. But then after 6 months, it kind of tapered out, and there was no more. So I think we can just faster spread the technology because much of the technology is easier to adopt, but not all of it. Okay. But if it easily comes, you can also easily lose it, or someone else can take it from you. So, for instance, Apache Spark took so many years to write all the books, get the universities to adopt it, and get all the ecosystem to adopt it. It took a long time. Well, it's going to be also now hard to displace it. So
do you see the progression from Databricks to from the Lakehouse and the more really LTAP, and I know you still do a lot of work there, but the transition to AI, is it for you a way to move from one S-curve to the next one, or is it for you just that is it an expansion of what you want to address, I would say, or is it just that you see every database or this becoming AI native in the future?
We were always doing AI, since day one. The Spark project was actually created originally to help some of the students at UC Berkeley who were, who wanted to participate in an ML competition, the Netflix prize, which was who can do recommendation best. So it was alternating least squares, matrix completion. So from day one, our bread and butter use case was always AI. But our problem was that we couldn't, it didn't drive much revenue because people were not interested in AI. So up until November 2022, so for, 8-9 years, nobody cared about AI. So that was our challenge. There were small machine learning teams that cared about it. But if you went up to the CEO level, nobody cared or understood what it is. And AI, it was called machine learning. And AI was robotics. And, so we were always doing it. We doubled down more on it. And you might hear us talk about it more because after November 2022, nobody can stop talking about AI. It's like can't get enough. It's like every conversation. Especially with CEOs or C-level executives, it's always AI, and they want to talk about it. So,
okay. So now they're calling you to say, now I need an AI solution.
Exactly. That is exactly. How can we, as fast as possible, adopt AI?
So when you do your project and the one I really like recently as an open source framework person was Omnigent, and how you do this meta harness to use everything and being able to basically mix cloud code, codecs, have all of this interface. I would say 2 things that I really like there. One of them is you still do that in a very open source fashion. Do you think this is basically a repeat of kind of the Spark maybe original story, that you think Omnigent will get a community and this will grow and maybe be something big?
Yeah, that was the whole strategy. I mean, we literally kind of went back to the playbook of 2009 to 2013. And literally looked at what did we do back then that was successful? Do we need to change anything? And so on. Databricks as a company already has its agents. We have these agents called Genie that are used by enterprises, and they can answer business questions. But we decided to still do Omnigent because the Genie agents that we have are awesome. Enterprises love them. But we wanted to go for something that has ecosystem and something that the community is behind. So that's why we went with Omnigent. And we thought that the industry really needs. There's so many harnesses out there, and then there's so much now. There's lock-in on some of them, and they're hard to use across each other. So we wanted just one layer above that just kind of creates interoperability and makes it easy to go across those and avoids, it basically gives you a choice. It's very similar to actually the original project that we had started at Berkeley back in the day called Mesos, which was the same thing. Okay. It was a second-level meta scheduler, actually. For at that time, the schedulers that existed. So this is a similar idea, but instead of schedulers, it's harnesses for AI. So it's a very similar idea. But yeah, we hope that the community, and we've already seen, we were encouraged. I mean, there are over 100 contributors in the project already, on the open source project from all over the world that are contributing to it. So I think it's very exciting. And I think we're going to see more actually open source going forward, thanks to AI, than we saw in the last decade.
Yeah, I'm the same. I also try to always put my old project that I couldn't really get to fruition back in the new one, saying, oh, we should actually try to do that now. Maybe now is the right
Lower
time.
cost to do it now, yeah.
It's always true. It's true. I think, so among all of the things you cover in this project, you cover closed model, you also cover open models that you can use in this harness, for instance. And you also have this specificity that since you have, for instance, the Mosaic team, but even before that, you were training actually LLM model, like there was the famous Databricks model.
DBRX, yeah.
DBRX was great, was large, was powerful.
It was the best open source model for a whole 3 weeks.
Yeah, it's a tough one. How do you see the open source models, right? A big topic today is, of course, like how to train more models? What do you see? What's your opinion there? Do you think it's very important to have a very large? Do you think we should play with all of them? Do you think every company should train their own LLM or fine-tune them? What's your?
No, I think it's cost prohibitive. So train your own, or pre-train at least, is cost prohibitive.
You still did it back in the day.
We did it. It cost us, less than 10 million to train the actual model. The actual model cost 4 million to train the actual model, but the cluster cost us $20 million at the time. So that gives you a sense of what was needed to be the best open source model in Q1 or Q2 of 2024.
Yeah.
Now I think the costs are in the billions. So I think if you want a really good frontier model, probably have to pay a couple $1 billion for the model, and I don't know, the cluster might be $10 billion. So it's nothing that, most companies cannot afford that. I think that the industry really, really is in dire need of open models that have been trained and the weights are free. And I think it's gonna happen. I just think that for some reason, the pendulum has kind of swung. If this was 40 years ago or like 20 years ago when I did my PhD, this would have been a supercomputing center would have done this, right? When I was doing my PhD, the largest computers on the planet were all supercomputing labs, and they were all government funded, and that's where they did all the big compute that it was called high performance computing, right? HPC. So that's how we would have done it now if we had followed that paradigm. I think we're going to go back to that paradigm if I'm honest, because I think it's open. I think that LLMs are so critical to governments, to companies. To democratization. So it has to kind of go back to that there's going to be open models that have been released by these kind of maybe consortia, maybe some industry is involved. But the big challenge is the funding here, right?
Do you think we should push for a big cluster in the US, like 100, 200,000?
Yeah,
100.
Yeah, I think you can collaborate, right? Kind of like the SETI at Home project. You could have, a little bit of a run in this supercomputing lab. You could have a little bit of the run. By the way, that might be also politically much viable. That parts of it is trained in Europe, parts of it is trained here. Maybe some other supercomputing labs. I think it's going to go towards that. The actual training of the model, in my opinion, is not that hard. At least I don't think. I don't know what I don't know. So ignorance is bliss. But I think that it's doable. It's not like impossible rocket science. It's the big problem is capital and GPU clusters. And if you pool resources, I think it would be possible. So I think that will happen. That's been my prediction for years.
Interesting, yeah. So we did one project like that in 2021. We found a cluster. At that time, you could train on 1,000 GPU was a lot. So we found a cluster with 800, and then we pushed the government to, it was A100.
Yeah.
And then the government added some, so we had 1,200 GPU.
Nice.
Could train something. Now the threshold is a little bit higher.
Exactly.
Like, I think.
Yeah. I need B300 then. Yeah.
Yeah. What's your so you had this very interesting multiple life where you were like you were a PhD student, professor, then entrepreneur, and then CEO. If you were to give advices on the younger self of you, let's say at PhD level, or even before PhD, I get all the time this question: should I do a PhD or not? And should I actually do that in this or these areas? What are your usual advice for people this age?
Good question. I'm not a big fan of, I wouldn't change anything because I wouldn't be who I am, kind of BS. But I don't know. For me, academia was very, very good because it taught me to think from first principles and ignore anything that's out there. whatever people say, whatever the opinions are, whatever is common wisdom, just ignore it and go from first principles. And that kind of logic-based thinking. I think I studied mathematical logic, and it was the greatest course I ever studied in my life. It changed my life. So for me, it's very, very important, I think, especially in this age of, there's so much disinformation, and there's so many different channels of noise, and things are so polarized. And also in the AI space, there's so much, people feel like, oh my God, I have to stay on Twitter and I can't keep up. And if I just step away for an hour, I've missed the big revolution of AGI and so on. And I think if you just go from first principles and there's a lot of noise. And there's actually not that much happening. Things move kind of slowly, and you don't need to get super, worked up about things. There's in the world, there's a lot of hysteria. But if you just go from first principles and look at those things, it's not much is actually happening. I mean, things are happening, but it's not as crazy as people are making it sound. People think we live in a singularity right now. So that, I think for me, maybe that doesn't apply to other people, but academia really helped me to ground me in kind of facts and science, try to strive towards that and work from that. It also helped me build a company because there's a lot of oh, you should do it this way and we should do it that way, and this is how everybody else does it. But it helped me just think from first principles. How would you build a company if you were building it? What makes sense? And let's not do it the way everybody else does it, just because that's the way so-and-so did it, or this authority did it, or that book says that you should do. Yeah, I'm a big fan of academia, and I think it's going to be around, and I think university will be around. Education is one of the things that I find is kind of interesting is people say, oh my God, they're not hiring any junior people anymore because in programming, computers can just do the programming and they're not going to hire, so then they're just keeping the senior people. So then we're going to have this gap, this big air gap of where we don't have any people. How are people possibly going to learn how to build things if we don't employ them? Well, hello, there's a university system that literally prepares you. So we just need to change that to prepare them for whatever they need to, whatever the job is. If we need to produce senior architects, then train people to, become senior architects. We don't have to teach them long division for 9 years. We can change it up. So I think this is going to be a really important place. And I think AI will also disrupt education in a really good way.
Should people still really learn long division, or should just learn how to use LLM to fill all the gaps of their future knowledge?
Yeah, I mean, I don't know about long division, but there are other things that are better, right? So that I think we can update the curricula. But I also think how we learn is going to change with AI because it's an amazing tutor. And we can personalize it. So, every person learns differently. And, there's people have learning disabilities. Some people learn visually. We have gaps in our understanding. I think you can just personalize it so well here. It's already obvious that you can. So I think it's a huge democratizer, AI. In education. So I think that's going to be awesome.
I fully agree.
I'm trying to push my kids to do it, from early age.
Which age?
4, and so I'm teaching them to use it, early. And guess what? The interface is English. So as soon as they can speak, they can kind of start getting value out of it.
Using that, yeah. Yeah. We had that last week with my 13-year-old. He was struggling on his history book, and I was trying to read that. And I said, you know what? We're just gonna dump all of that and ask ChatGPT to make a comic book for you around that. So
yes.
you read the story of someone living in these values that was around middle age and things. And that was just way more graphical and interesting.
Yeah.
So.
Yeah, they can learn so much more. My kids already know so much more than I knew. And I think I had the same curiosity, but I didn't have this technology didn't exist. Even getting access to books. Here you can just keep interacting and asking questions, and you can go at your pace and your level of understanding and ask whatever you want. So it's a game changer, I think, from a learning perspective.
I think it changed also a lot. So for instance, there is all these stories around indeed interns not really finding jobs. And I've seen mostly the opposite. And I had the same on stage this morning with, I was chatting with Minimax. So they have this very nice M3 model, which has a sparse attention. And where did this sparse attention mechanism came from? Did you had already an agent finding that, or was it still a human? She was like, you know what? Our interns are actually the smartest because they can find all the answers, but they still have maybe more freedom to think a bit crazy ideas than some of the more senior. And so they came with all these things. Some of them doesn't work, but this one with a double, a double challenge for attention work really well.
Yeah.
And so I think actually people can be pretty young and can already push some ideas really far with LLM, basically.
Yeah. Yeah, I mean, I think we hired 200 interns last year. We have we spend a lot of time on university recruiting, And we have a lot of people that do that. And the consensus, I think, at the Frontier Labs, at least for many of the Frontier Lab folks that I know, that I talked to, said that, look, it's hiring junior people is just not worth it. You need experienced people. But we look at the data at Databricks, again, from first principles, and we just look at who's really good in our existing. And it's actually kind of interesting. There's quite a bit of young folks that are very, very good with the technology. It's just the data just shows it. They're just way more effective. I can't get into how, but they just use the AI differently. So we decided to double down on new college graduates. So this year, sorry, not interns, new college graduates. Some of them are interns that we convert. So we went from 200 to 600 this year. So increased significantly, actually. So it's awesome.
I think we're the same. What I saw actually for Frontier Lab was it was very per lab dependent. Some of them really focus on more senior folk. I think Anthropic is the most senior, and some of them, like OpenAI, has a bias for like younger folks. And actually, if you look at OpenAI history, for instance, some of the, for instance, Sora people, or even before, were actually pretty young people that they gave a chance to try their crazy idea out of basically master.
Yeah, but we're just hiring directly out of college. We call them new college grads. Many of them are interns that we convert. So we already sign. They do an internship, and we give them a return offer to come back and work for us. So that number increased, 3x this year.
Nice. I think we can take a couple of questions if we have also, because it's a pretty small audience. So if some of you want to ask a question to Ali. Andy, yeah.
Hi, I'm Laura Bratton with The Information. Ali, I believe I asked you this during the Databricks Summit, but just since it's been a couple of weeks, I'm curious, since you guys recently launched the Unity AI Gateway, how you've seen enterprise demand for open models change, and any trends you're seeing there, since you're kind of at a unique position in this whole space right now.
Yeah, I would say, Chinese models in particular, over the last year or two, people were skeptical. They didn't want to use Chinese models until their costs shot up. Then they all want Chinese models now. So that switched very fast. It went from, we don't use Chinese models, to like, give me the Chinese models. So yeah, they want to use GLM 5.2. Everybody's interested in GLM 5.2. Before that, it was Kimi 2.6. Before that, it was Kimi 2.5. In January, it was Kimi 2.5. In March, it was Kimi 2.6. And now it's GLM 5.2. And various, lots of others. And there's the models, Gemma, and other models as well, that are made here in the US and elsewhere. So yeah, people want really, there's a lot of questions now about why are we using the smartest models for really, really simple tasks, and why are we paying so much money for it? Just so many companies are blowing through their budgets too fast, and it's starting to become cost prohibitive for them. So the way they think about it is that the revenue of their companies, like our customers, their revenue is growing much slower than their cost of large language models. So if this continues, it's like just unsustainable and almost company ending, which of course they're not going to let that happen. So they want to find ways in which they can curb it. And there are very effective ways in which you can do that. You just need a router that, for the simple tasks, picks simpler models. And you need good caching, and then really good governance so people know what they're spending. Because oftentimes they don't even know. Like they'll tell you, oh, this was not a big, this use case. Someone said there was a customer that said that they had, I forgot what it was. Someone spent $200,000 or something. And then they looked into it, and it was someone who just was trying out some image model thing just for fun on the side. And that just blew through more than an annual salary, or on par with the annual salary. So just giving visibility to people is super helpful. So that's also a big part of what we do. So everyone knows how much they spent, and they get alerts, and they can get warnings. So there are ways in which you can significantly bend that curve, and everybody's interested in that right now.
Hey, great panel. Remzi, Arpaci-Dusseau, University of Wisconsin. First, a comment, just really agree with you on the educational piece. I think it's such a democratizing tools are here today. I remember talking actually with you, Ali, some time ago about how you used tools in an educational setting to quiz yourself, learn your weaknesses, and then dive into the things you want to learn better. And I've noticed that a lot of students have figured out these patterns too. And yes, it's increased, it's caused the death of the office hour at some level.
Yeah. Is that good or bad?
But it's like, in the middle of the night when no one's there to help you, actually there's someone there to help you. It's just a tool. But I was curious, you made a kind of maybe a provocative side comment about your thoughts on AGI. And I just wanted to hear maybe each of you talk about that a little bit more.
Oh, okay. Yeah, happy to go there. Yeah, look, my view is, well, let me ask you this. How many believe AGI is here? Hand up. One person? Any brave? Two people? Giannis thinks so? So 2 people here thought AGI is there. How many of you think that the models, the frontier models that you're using are smarter than most of the people that you work with most of the time? Come on, don't be shy. Okay, at least half. Usually I get like 90% hands here. Okay, so AGI is already here. Okay, any definitions of AGI that we had, let's say 5 years ago and before, we've already satisfied that, and we're beyond that. So I think we already have AGI. The models are plenty smart. The frontier labs are focused on, humanities last exam, HLE. That's like the thing that they're focused on. Usually I do this joke. I ask this question from the audience. How many of you can solve the following? Find the 12-dimensional spin Bordism of the Lie group G2. That's a question from HLE, actually. How many? Shout out. Maybe François knows the question. Probably. He's the only guy that knows the question here. Okay. They all crushed that question. That's like that's easy. That's a layup. And we're at, I think, 50% of HLE anyway. We're at 50% of answering questions on humanities last exam. But the most things that we want agents to do and AI to do is actually not of that. Of course, we want to solve cancer, and there are some science things that are like at that frontier. But the vast majority of impact that we want AI to have in everyday life, it's plenty of smart to do that. You just have to give it all the context. And today, the AI has a big context gap. It doesn't know what we're thinking, decisions that we're making. It just doesn't have all the information. If you give the perfect information or context to the current frontier models, they will crush pretty much any everyday task that we care about, okay? Except for like maybe some frontier, like solving, some very difficult, like, scientific questions. So in other words, we already have AGI. It just has a context gap. How do we get the context into the AI? That I actually think is going to take, 10, 20 years. So I don't, everybody's like, oh my God, the world is going to come to an end. And, some people are talking about 20% unemployment and whatnot. I think it's going to take 10, 20 years. Pretty much every previous economic disruption took forever. My favorite example is if you look at, the 1800s, pretty much all the factories back then were running on steam engines. And they were set up in this way in which they had a steam engine in the middle, and then they would have this line shaft that would run the whole factory. So they would pack these factories extremely dense, multi-floor. They were like kind of dark because you didn't want to actually affect the equipment, and everything would run at the same time through this steam engine that would run. When electric engines appeared in 1840s and then became commercially viable everywhere in 1860s, like you could get them anywhere, like very cheaply, they started actually buying these and started upgrading all the factories to using these electric engines. They saw 0 productivity gains from it in GDP growth until 1920. So it took 40 years. And the reason is when you study like why that happened, I think that kind of tells us a little bit what I think is happening with AI and what's going to happen with AI and the context problem of agents right now, which is they would go to the factories and they would replace the steam engine with an electric engine. That's all they would do. Everything else in the factory stayed the same. And so then it's like, okay, we're not getting much benefits out of this. It took 40 years until they completely redesigned all of the factories to change the floor plans, to move them actually out of the cities, not have multiple floors, and then switch unit drive to group drive, which means the whole factory doesn't have to run at the same time, and everybody does not have to come in at the same time. You could actually have an electric engine that operates different parts and so on. The reason I went through this long, weird, esoteric example is I think it's a good analogy for, I think, what's going to happen in every organization today. We need to rewire all of our factories and completely change the floor plans and redo all of our processes for the AI to have the effect that we want it to have. And that just takes 10, 20 years. It's nothing that happens like overnight. Another example, you might say, okay, that's such a crazy example from hundreds of years ago. I can't believe this guy knows that example. That's not relevant. Well, let me give you another one. When the PC arrived, what people would do is they would just take the PC and they would replace the typewriter with it. And they saw no GDP productivity gains from it either. So what were they doing? They were putting the PC there. They would type it as a typewriter, print out the sheet of paper, and then archive it in like folders. And then they would have people that go like look them up and index them and write indexes and so on. So it took a long time to just get society reorganized around that. So I see it in my company because we have 10,000 employees or maybe 11,000. And I just see how hard it is to change the processes. And we're not like a super old 100-year-old company. We're like 12 years old. But things are just ingrained in the way we do things. And changing that to really incorporate agents and AI into it. There are plenty of smart already. They don't have an intelligence problem for Databricks. But changing Databricks so that it can really fully utilize them, it's going to be a journey. It will take us, and we're like, I'm super into it and want to do it. It's going to take us many years. So that's my view. Sorry, that was a long answer. But basically, I think AGI is already here. It's like a red herring to talk about, oh, when are we going to get AGI? We already have AGI. Now we need to rejigger all of society to adopt the AI, and it's going to be decades to do that. So, people can chill out. Sorry, that was a long rant.
I'll be a bit shorter. But I really like your
I ate up the whole time.
So many stories. I agree on that. I think a lot of what we discover is a lot of the thing we do are mostly remembering knowledge and doing some form of pattern matching. And these models are really good at both of that. And I was a former lawyer, and I can definitely, when I started to see what this model were doing, I was like, oh my God, all my former colleagues are just cooked, because most of what we were doing as a lawyer was learning about like facts or case and just pattern matching to what's there now. And I think that's very true, and that's why basically it will have an impact. That's crazy. Now today, for a lot of the things I think we care about, I still think they are lacking a lot. So for instance, me, I try to think about new product we do. I try to work in robotics or science, and I think they are, like, as soon as you want them to start proposing something surprising, new, and actually outside of the expected. And a lot of the time, even as a researcher, entrepreneur, you will try to find this place where people will be like, wow, this thing is surprising. It can be a result like of a research, or it can be just a new product. And I've never really seen yet this type of spark coming out of a model, right? Like I try a lot of ways to ping them. I say, now try to explore every possibility and try to find the most uncommon and unexpected thing. They're still pretty bad at that. And I think by constriction, they will just keep mapping the space of what existing. And every time we have a new benchmark, they start mapping the space of what is benchmark cover and just fill the probability gap, right? And so we keep seeing them more and more powerful. And I like how Darius said, like, powerful AI instead of AGI. We don't agree on many things, but this is one thing we agree on, I would say, which is we'll keep having more and more powerful AI. But I'm still really waiting for them to have this spark where I'll be like, oh, wow, that's a novel thing that I really find interesting, either as an entrepreneur or researcher, whatever, just like something. So please try to find a way to do that, and then I'll be happy. And so usually my bar for AGI is getting an AI to get a Nobel Prize for something. I don't count AlphaFold as that. Otherwise, it would have been to be self-developed itself to get to this. And maybe we get that, but I don't think we're there yet.
All right, next question. Over here, center.
Hey, Ali, Alex Heath, Sources, good to see you again. I want to actually follow up on the first question. So I think we all agree the era of token maxing is quickly coming to an end. You were saying that companies looking to cut spend. What do you think, though, is going to be the impact on the token providers if you were to underwrite kind of the second order impact of what you're seeing with your customers and what they're looking for? Yeah, how would you extrapolate that out to the labs that are providing the tokens?
Yeah, look, I think that it's kind of going back to my, it's going to take decades to get this technology ingrained everywhere in society and use it thoroughly. Just even if we completely stop all intelligence work right now, just freeze the models at its current level, I think we have plenty of intelligence already. It's still going to take a decade or two to get it to be everywhere and we can get value out of it. So I think we're on a secular trend of decades of being able to get much more value out of it. And I think that, as it pertains to revenue and the success of those companies, I think they'll continue to be on this secular shift of doing better and better. And many, many other companies that people will start, hopefully based on open source technologies. The current value, token maxing turning into value maxing, that I think is a speed bump. So yeah, I think it hurts the revenue, and you'll see people bending the curve, and it affects people's revenues right now. But it's just a little speed bump, and we'll get over it. Secular trend is going to be for a decade or two for the whole planet to go through this kind of big transition throughout. And I think it's largely is going to be great.
Yeah, I think the unit the token was the proxy to what we really want, right? So I think your example of basically using $200,000 just to generate image, these are what I would call stupid tokens. Right now, some tokens are stupid tokens. I think some tokens are intelligent tokens. The one that solve your bug, they're worth a lot. The one that just generate bullshit image are not worth a lot for your company. And so we're just start now to have better metrics, which is basically what's the bottom line impact and how can we measure that. It's harder to do, I think, to really understand well, that's what you do really well, but what's basically the usage of your company? Is it a good usage of token? How can we benchmark all of this?
Yeah, makes sense. By the way, just to go back to Remzi's original question, I didn't answer one part of it, which is you said when do we have AGI? Then there's the whole superintelligence, which is what a lot of people are chasing. Do we get to superintelligence? And I don't know how they define superintelligence, but if they define it like Nick Bostrom does, the 3 criteria he has, that it's in a blink of an eye, the AI can read all of the research papers on the planet and come up with things that would take a PhD student 10,000 hours or something like that. And if that's how he defines it, right? That kind of superintelligence, where it's recursive self-improvement and it's takeoff and singularity and all of that, I'm not very worried about those risks personally, because the way I think about it is every new model if you look at how actually the labs are training model, the next training run is more expensive, more complicated, and more humans involved, and more we got to be really careful and make sure that we don't screw this one up and that it goes well. It's the opposite of what you would have expected if we're going towards that kind of recursive self-improvement loop, where you would expect that the next, GPT-6 or GPT-7 costs $1,000 and takes only a week, and the next one costs $500 and takes 3 days, and then the next one, that's not really happening, right? It's going in the opposite direction. It's bigger and bigger clusters, harder to put them together, and we kind of have all the physics against us on the pre-training side, which is, okay, so now we have, I guess Colossus is 500,000, GPUs. What is it going to take to get to 5 million GPUs and 50 million GPUs? And by the way, out of each of these, we only get a small linear improvement because intelligence is logarithmic. So, I think those fears are also kind of overblown. And then the job fears that I also mentioned, I think those are also overblown. Since I mentioned, I think it's going to take many, many years. I mean, I'm just looking at my own company, how hard it is to transition. And I have many, many anecdotes I can share where we try to put AI and automate things, and and people are very optimistic with those projects. We're going to get it fully automated, and it's 6 months later, it's it takes a little bit longer than I said, but give us another year, and then a year and a half later, it's okay, it's going to be a 5-year thing. So it just turns out it's very, very hard to take an existing process that has accumulated over many, many years and completely refactor it. And make it just automated. It's going to be a long journey. Sorry, that was not a question, but I just remembered.
It's like Claude Code saying it's going to take 2 weeks and then it's done in 1 day, but actually it takes 2 weeks to iron out the bugs. So actually it was true in the end.
Yeah.
Hey guys, so I want to touch on an offhand comment you made, which is the death of the office hour, which over the whole day today and actually this weekend, that's the thing that scares me the most, because when you raise your hand about AI being smarter than all the other people you know, and a lot of the themes of the conversation today is how do we talk more and build in the open and create a community and make those connections that drive new ideas and innovations. But with AI, we don't have the excuse to go talk to people and have these happenstance interactions. So as someone managing a community in an organization, and you're trying to figure out how to build around AI, are you thinking about how you can preserve those interactions when we have less reasons to talk to other people?
Yeah, I mean, look, I think that humans like humans. We're a social animal. And genetically reprogramming that's going to take millions of years. So I don't think that's going to change. So that remains the case. We're going to do it that way. And we're going to want it that way. For myself, I've been a believer of that. During COVID, when everyone's everything's going remote, everyone's going to do Zoom meetings, we're going to have distributed offices. I was do not hire anyone outside of our offices. I literally had a rule. When all the offices were closed, I thought from first principles, this makes absolutely no sense. So we only hired people that were within an hour of our office. Now, they had a bizarre case for the SF office. Turned out by the end of COVID, everybody was in South Bay, and we had to open a South Bay office. But they were all within 1 hour of our office. So yeah, we believe get people back in the office, make them work together. Great ideas come when people work together. But more importantly, you build trust and human bonds when you work together closely. And trust is the most important thing in an organization. So that's the thing. The only way to build trust is to work together closely over a long period of time. There's no cheat code. You can't like, oh, I can figure out how to trust the person very quickly within an hour, 100% with my life. No, there's no such thing. It takes a long time to build it. So I don't think those are like human qualities that are not going to go away. So I'm not too worried about that. I think in terms of open, I think we didn't get to talk about it too much, but I think open source is going to have a huge boon in the future. Like I think we're going to see an absolute explosion of open source. We're just at the very beginning of it. Like it used to be like, in research, there's this famous or infamous paper that, one of the, Unix folks wrote, Plan 9. It was called System Research is Irrelevant, I think, something like that. Right? Systems research is irrelevant going forward. And if you read that article, it's essentially the essence of it was you can't really build complicated systems anymore because it's just too much stuff that you have to build, and you simply do not have the resources to build them in open source anymore. So the only people who can build like very advanced systems are like very big companies like Microsoft. In fact, when I started my PhD was in programming languages, and they stopped the lab I was in, killed the project and said, we're not going to do programming language research anymore because it makes no sense to do that in academia or in a research setting because there's so many libraries you have to build. It only makes sense for like companies like Google to build them, or Sun Microsystem at the time. I think this is 100% about to change. It's just so much cheaper now to write software. So I actually think that open source software now is going to flourish. We saw it with Omnigent. We built Omnigent in a very short period of time. Like this project was built at an insane speed. It's like unbelievable how fast and how much capabilities Omnigent has. I mean, it's built in like 2 months or something like that. It's unbelievable how fast they built Omnigent. So I think that we're going to see a lot of that in open source happening. The other thing that I think is sometimes overlooked is that frontier models or LLMs love open source. We actually saw that in some of the research that we did because we have some competitors at Databricks and they're not as open source friendly or as pro open source. And we saw that the large language models were preferring our software stack. And we were confused ourselves. And I asked the question, how come they are recommending us? And how come the large language models prefer our software? And someone at Databricks said, oh, it's because we have the best documentation. And we write such great, beautiful documentation. And I was like, well, that's not true. We don't have better documentation than anyone else. So we started looking into it, and we started doing research in it. And it turns out that large language models love open source projects. Why? Because they can memorize the whole source code, and they understand it, and they can troubleshoot it, and they can fix it. Because the whole source code is available. And they have remarkably good understanding of like a giant project like Apache Spark of millions of lines of code. So the models will prefer open source. And I think we can build open source easier than ever before at lower cost. So I think there's going to be a huge explosion of open source. And I think the same dynamics with communities and so on and ecosystems are going to apply around it. So I think it's going to be a great time for open source actually going forward.
Yeah, I agree. I think for creativity in general and building new things, this is just going to be a boom. I was having the same type of discussion with Scott Belsky, who is doing A24. Was like, I was asking, do you think movies industry is going to die? And say, no, it's going to be the complete opposite. It's going to be a huge boom of creativity. We still see now in our place, like some open source maintainer don't really like the new way of building that's very automated. And they're kind of like, we used to craft this like sculpture, and now people are just doing. So, yeah. I think the open source community will change. It will be a different type of community.
It'll be great. And I think it's going to be more of it because the cost just went down to write software.
Yeah.
We're going through some birth pangs. Like, I mean, there's some problems right now. Like, AI slop and tech debt and data models that are broken and so on. But we'll figure it out. We'll figure out ways around that.
One thing I'm worried though is the like getting no new programming language, or basically by the fact that models tend to bias for, like you were saying, for things that are really heavily in the training data set. Like how do you want to create a new programming language and get adoption today? You need to wait a couple of generations of foundational model that they start to train on your own language so that people start using that to write. So I'm curious to see where this
Let me give some counter to that. I think we're going to see great, amazing programming language research happening going forward because the programming languages are all built for the wrong thing, right? They were built for humans. But it's not humans writing the code. Let's face it, humans are not really writing the code anymore. The large language models are writing it. So like, for instance, we see like a huge shift towards Rust. Why? Because Rust compiler is kind of tricky, and it's like, you have to battle it a lot. which is great. Let the large language model battle the Rust compiler a lot, and if it passes the compiler there, you have something that's pretty robust. So I think we're going to see a shift to programming languages that are better for AI. I also think that we need programming languages that are easier for humans to verify, because the verification is still there, right? In everything, by the way, legal practice, medical practice, but also in programming. We need someone that's like, hey, did you verify this thing that's going to blow up something, like if a big disaster happened, who verified it? So you need a human in the loop that can verify if it's good. Right now, humans have to verify millions of lines of code that these things are producing. I think we're going to come up with new abstractions and new ways in which the form factor of the programming language is perfect for verification of humans, and also perfect for LLMs to produce it and compile it and verify it and check it and so on. In terms of like, oh, well, it's sunk cost. We have the whole web, and they've trained on Python. There's no way you can beat Python. Well, I did the calculation on this, and I think that we're going to write more lines of code. You can actually back into this number yourself. There's many ways to triangulate this, but over the next 9 months, if you want, you can round it to 12 months. More software will be written than ever in the history of mankind. You can go back and do that. You can extrapolate this from the GitHub repos and their stats and so on. So we're going to see more software being written in the next 12 months than ever in the history of mankind. So you could easily produce a lot of code in your new favorite programming language that doesn't exist yet. And there's going to be more code written just in the next 12 months. And how much Python we have in the existing code base is it's going to get dwarfed in a couple of years by whatever new programming language we're going to come up with. So, I think it's a great time to innovate, come up with new things, and I think open is going to be a great way to do that.
We agree.
Yeah.
I think there will be a way better language for LLM that could come, and then you very quickly could translate a lot of code base in this new language.
Yeah.
All right. What a heartening end to a day of programming called Open Frontier on the live stream. Let's thank Thomas and Ali. Okay, and that's the end of the live stream. So we're going to quickly move as a group back to where we ate lunch. For the next about 1 hour will be a group conversation in salon format. It's Chatham House rule, which means that you can't cite whoever said a thing, but you can talk about what we talk about there. And there will be 5 topics, which will be moderated by volunteer moderators that we've got picked out. And we'll see you over there. Don't leave things in this room. Bring things with you. There's food and alcohol in the other space that we're going to right now. Let's move quickly so we have some time. We'll have about an hour to do our salon. So yeah, let's head on over.